Hello, good evening. Boys and girls, please respond. Am I audible and visible? Harsh Thakkar, Bhargav, Rohit Chauhan, all clear. Okay, very good. So, boys and girls, very good evening. Welcome to Unacademy platform. This is Dr. Khaleel. Welcome you to this Maha Revision second part 2. I hope you're all doing very well. और ये भी मान के चल रहा हूँ कि आपका प्रिपरेशन काफ़ी अच्छा होगा, अच्छा चल रहा होगा, राइट? So, very happy to see you back for the second part of operating system, Maha Revision. और आज के सेशन में हम स्टार्ट करेंगे थ्रेड्स एंड मल्टी थ्रेडिंग से, प्रैक्टिस क्वेश्चंस लेंगे एंड देन वी विल गो विथ सिंक्रोनाइजेशन, डेडलॉक्स एंड देन इवेंचुअली मेमोरी मैनेजमेंट. ये हमारा डिस्कशन होगा आज का, ठीक है ना? तो चलिए, विदाउट वेस्टिंग मच टाइम, लेट अस क्विकली जंप इनटू द टॉपिक ऑफ थ्रेड्स एंड मल्टी थ्रेडिंग. ठीक है, तो देखिएगा, व्हाट इज अ थ्रेड. जैसे कि वी नो थ्रेड इज अ लाइट वेट प्रोसेस. थ्रेड इज अ पार्ट ऑफ प्रोसेस विद द बेसिक फिलॉसफी ऑफ शेयरिंग द एड्रेस स्पेस. क्योंकि जब मल्टी प्रोसेस अप्रोच से आप प्रोसेसेस क्रिएट करोगे, देन बेसिकली एवरी प्रोसेस विल हैव इट्स ओन इंडिपेंडेंट एड्रेस स्पेस. दैट विल लीड टू वेस्टेज ऑफ रिसोर्सेस. तो उसकी बेसिक ड्रॉबैक को ओवरकम करने के लिए द अप्रोच और द कॉन्सेप्ट दैट वी हैव is to go for multi-threading, right? So within a process, within a single process, we are going to create multiple threads. We are going to create multiple threads, where the basic objective of multi-threading is to go for resource sharing, to have economy, to have resource utilization, better or effective resource utilization, right? So देखिएगा यहाँ पर, it's a lightweight process. Generally we write in short as LWP. In multi-threading, the threads of the same processes or same process share the user address space, files, signals, and other resources. In multi-threading, each thread has its own stack. So, काफी questions आए हैं पिछले एग्जाम में with regard to this aspect or this property. What is common between the threads? What is independent to each thread? So, no two threads will share the same stack. Has its own stack. Thread ID, thread CPU state information. That is the thread control block. देखिएगा, every thread will have its own stack pointer. Every thread will have its own scheduling information, that thread state, priority, etc. लेकिन address space, other resources like files है या semaphores है या IPC mechanisms है, all those are basically shared. All those are basically shared. So that is the meaning of it. What are the basic benefits of multi-threading? यहाँ पर देखिएगा स्लाइड पर. The basic benefits of multi-threading are improved responsiveness, faster context switching, effective utilization of multiprocessor system because you can schedule different threads onto different CPUs on different cores. So therefore, multiprocessor. Enhanced throughput of the system. System become economic. So therefore, these are the relative benefits of multi-threading. These are the relative benefits of multi-threading. आगे बढ़ेंगे, ये छोड़ दीजिए आप. हाँ, next important aspect is types of threads. So let me write it down here. Let me write down types of threads. So as we know, as we understand, there are two types of threads. One is user level threads, the other is kernel level threads. Threads that are created, managed at the user level without taking support from operating system. जो threads आप user space में create करोगे without taking any support from operating system, ठीक है ना? Because this is the flexibility that you want. आप जिस तरीके से चाहो threads को create करना चाहोगे. So that is not possible in multi-process approach. That is only possible in multi-threading approach. So user threading basically allows you to create, manage threads at the user level without taking any support from operating system. That is called user level threads. That is called user level threads. Yes, correct. Rakesh Joshi is correct. Java threads, P threads are example of user level threads. So अगर आप बात करोगे user level threads की, यहाँ पे देखिएगा points read करेंगे. These threads are managed at user level and these threads are managed at kernel level. Threads are not recognized by the kernel. So this property is called transparency. User level threads are transparent to operating system. Those are anyway recognized by the kernel. They are implemented as independent threads. All user level threads of process can run one processor on one processor and only one thread at a time. हाँ, second important drawback of user level threading is that जो गेट में कई बार आ चुका है क्वेश्चन, blocking of one user level thread would result in blocking of the entire process. जब भी कोई user level thread require करेगा IO ऑपरेशन को, that will result in blocking of the entire process. So that is the drawback of user level threading, for which you have to go for kernel level threads. So that is the drawback. Okay, these threads have less smaller context, so therefore user level thread switching is super fast. User level thread switching is super fast. Why? Because there is no need of mode shifting. जब आप mode shifting में user level mode से kernel level mode में जाओगे, then basically you need some time. तो user level threading में there is no mode shifting, and that is why user level thread switching is super fast. ये गेट क्वेश्चन. आगे आपको एग्जांपल बनेगा. No hardware support is needed. Implementation is easy and simple. So this is a very good diagram illustrating the differences between user level threads and kernel level threads. आपको PDF मिल जाएगी, वहां पर आप ये फिर से एक बार देख सकते हो as a matter of final testing. तो जब when you have user level threads and kernel level threads both, then I need a mapping. So each I can have several mappings. I can have many to one mapping, I can have one to one mapping, or I can have many to many mapping. How user level threads are mapped onto kernel level threads. So therefore we can have different types of mapping. Yeah, Kiran, we are going to have memory management also, don't worry. So let's analyze. So one-to-one mapping is the ideal mapping which is generally followed in Unix and Windows operating system. ठीक है? One-to-one mapping का मतलब each user level thread is managed by one kernel level thread. Many-to-one is the example of user level thread. All user level threads are managed by one kernel level thread. और उसे हम बोलेंगे non-multi-threaded kernel. Yes, exactly, correct. So that is about the mapping of threads. Thread libraries अभी मैंने कहा Java threads हो सकते हैं या P threads हो सकते हैं या Win32 के भी threads हो सकते हैं. These are all examples of thread libraries which can be used basically by different operating systems. तो चलिए बच्चों, क्विकली बेस्ड ऑन दिस अंडरस्टैंडिंग थोड़े प्रैक्टिस क्वेश्चंस लेंगे. प्रैक्टिस क्वेश्चन से और थोड़ी अंडरस्टैंडिंग बिल्डअप होगी और आपको भी एक थोड़ा कॉन्फिडेंस मिलेगा. चलिए आंसर कीजिएगा प्लीज. ये PYQs है. PYQs में मैंने मॉडिफिकेशंस किए हैं सो दैट इट कैन बिकम ए पोटेंशियल गेट क्वेश्चन. चलिए आंसर मी द फर्स्ट क्वेश्चन बॉयज एंड गर्ल्स. आंसर द फर्स्ट क्वेश्चन. गुड इवनिंग अगेन दोज हु केम लेट. प्लीज ट्राई आंसरिंग द क्वेश्चंस and build up understanding. चलिए आंसर बता दीजिएगा चैट बॉक्स में. Which one or more of the following need to be saved on a context switch from one thread of a process to another thread? Need to be saved on a context switch from one thread to another thread. जब आप एक थ्रेड से दूसरे थ्रेड पर कॉन्टेक्स्ट स्विच कर रहे हो तो कौन से चीजें you have to save. Which of the following need to be saved? So boys and girls, let me tell you, this is MSQ. These MSQ question. चलिए कई बच्चे आंसर दे रहे हैं. यहां पर देखेंगे पेज टेबल बेस्ड रजिस्टर is not to be shared, right? This is shareable है. तो बेसिकली एड्रेस स्पेस के रिलेटेड है. it is shared, so I don't have to save. Stack pointer compulsory has to be saved. Program counter compulsory has to be saved. General purpose registers have to be saved. So therefore your answer is B, C and D. B, C, D. Many people gave the correct answer. चलिए नेक्स्ट क्वेश्चन पे आएंगे. ये भी देखिएगा MSQ क्वेश्चन है. ऑप्शंस है ABCD. MCQ बोलेंगे, नॉट MSQ. MCQ है. चलिए आंसर बताइएगा प्लीज. Come on, tell me the answer. Which of the following is or are not shared? यहां पर देखिएगा is or are not shared. So multiple things may not be shared. This is an MCQ. So you have to give me the correct answer, A, B, C, D. A, B, C, D. चलिए स्टार्ट करेंगे. Program counter has to be shared. Program counter is not to be shared. Every thread will have its own program counter. So therefore, this is correct. Stack, every thread will have its own thread, right? And address space is shared. This is shared. Registers are not shared. So therefore, this is the correct answer. Which of the following, यहाँ पर इंटरेस्टिंग बात यह है कि आपको गौर करना है. These are not shared. Program counter is not shared. Stack is not shared. Registers are not shared. Address space is shared. तो मतलब 1, 2 and 4. 1, 2 and 4. Option A is very correct. कई बच्चों ने आंसर सही दिया. आई एम वेरी हैप्पी अबाउट इट. चलिए आ जाइए नेक्स्ट क्वेश्चन पर. टेल मी द रिस्पॉन्स ऑफ द नेक्स्ट क्वेश्चन. गिव मी द रिस्पॉन्स ऑफ द नेक्स्ट क्वेश्चन. बहुत सिंपल है, PYQ है. थ्रेड्स ऑफ ए प्रोसेस, ग्लोबल वेरिएबल्स और हीप जो है ना, वो इट इज ऑलवेज शेयर्ड बिटवीन थ्रेड्स. इट इज ऑलवेज शेयर्ड. ग्लोबल डेटा जो है, हीप डेटा जो रहेगा प्रोसेस का, दैट विल बी शेयर्ड बाय ऑल द थ्रेड्स. सो देयरफॉर एज मेनी पीपल आर सेइंग द करेक्ट आंसर इज डी. द करेक्ट आंसर इज डी. बिल्कुल सही जवाब, आंसर इज डी. चलिए नेक्स्ट पे आएंगे. चलिए इसका आंसर बताइएगा. विच वन ऑफ द फॉलोइंग इज आर ट्रू? MSQ. कम ऑन बॉयज एंड गर्ल्स, प्लीज वर्क आउट. MSQ. Come on, work out. Come on, what is the answer for this? Okay. User level threads are not scheduled by the kernel. Yes, that is true. We will mark true and false. When a user level thread is blocked, all other threads of its process are blocked. True. Context switching between user level threads is faster than context switching between kernel level threads. अभी हमने कहा, this is also true. Kernel level threads cannot share the code segment. ये false है. तो बात गौर करने की यहां पर यह है, बात माइंड में रखने की यह है कि वेदर इट इज यूजर लेवल थ्रेड और कर्नल लेवल थ्रेड्स, एड्रेस स्पेस विल ऑलवेज बी शेयर्ड. ये तो बेसिक प्रॉपर्टी है यूजर लेवल एंड कर्नल लेवल थ्रेड की. इट विल ऑलवेज बी शेयर्ड. सो देयरफॉर दिस फॉल्स. तो एज ए MSQ क्वेश्चन द करेक्ट आंसर इज ABC. करेक्ट आंसर इज ABC. ठीक है. चलिए नेक्स्ट, इसका आंसर बता दीजिएगा प्लीज. इज ऑल्सो इंपॉर्टेंट MSQ क्वेश्चन. Niels Bohr, why you didn't attend it live? Now you attend live on Unacademy platform. लाइव क्लास हमेशा अटेंड करना चाहिए. come on, answer me this. क्या हुआ? हाँ हाँ. मैं जरा क्लास में हूँ, बाद में बात करता हूँ. मैं बाद में बात करता हूँ बनाना. लेट इट बी एमएसक्यू और एमसीक्यू, एमएसक्यू और एमसीक्यू आप डिसाइड करके बोलिएगा, आप डिसाइड करके बोलिएगा। देखिएगा जनरली आप ऑप्शन ये है कि इज और आर जब आता है ना, इज और आर, इज और आर जब भी आएगा क्वेश्चन में मोस्ट ऑफ द टाइम इट विल बी एमएसक्यू, ये बात याद रखिए हमेशा। जब भी इज और आर आएगा देन मोस्ट ऑफ द टाइम इट विल बी एमएसक्यू। तो चलिए देखेंगे यहां पर आंसर। A thread is usually defined as a lightweight process because an operating system maintains smaller data structures for a thread than a process. In relation to this, which of the following is or are false? आपको false determine करना है। First, on per thread process, the operating system maintains only CPU register state. क्या खाली CPU register state store करेगा? TCP में नहीं, you store other things like thread priority होगी, thread program counter होगा, thread stack pointer होगा. So therefore, this is false. Second, the operating system does not maintain a separate stack for each thread. False. It maintains a separate stack for every thread. Does not maintain is false. Good evening again. On per thread process, the operating system does not maintain virtual memory state. Per thread के ऊपर नहीं होगा. This is true. This is true. Does not maintain. Correct. क्यों? क्योंकि on per thread process नहीं. Virtual address space is common to every because एक ही प्रोसेस के थ्रेड्स है तो एड्रेस स्पेस कॉमन होगा ना, तो डज नॉट मेंटेन इज करेक्ट। ऑन पर थ्रेड प्रोसेस द ऑपरेटिंग सिस्टम मेंटेन्स ओनली शेड्यूलिंग एंड अकाउंटिंग इंफॉर्मेशन। तो फर्स्ट चॉइस रॉन्ग है तो सेकंड चॉइस भी रॉन्ग हो गई, फॉल्स। सो देयरफॉर व्हिच ऑफ देम इज फॉल्स इज आस्किंग, सो देयरफॉर ए बी डी। तो करेक्ट आंसर आपका बना ए प्लस बी प्लस डी, ए प्लस बी प्लस डी, ये है आपका आंसर। ऑलराइट, ठीक है ना बच्चों? Any questions or any doubt with regard to this question? थोड़ा slightly tricky है, लेकिन आपका कॉन्सेप्ट अगर क्लियर हो तो आप every option you can decide whether it is right or wrong. चलिए आगे बढ़ेंगे, इसका आंसर दे दीजिएगा प्लीज। Tell me the answer for this question. Very good, very good. Come on, do it. Solve this question, boys and girls. Come on. Asif, Negi, Rakesh, Shishti. Give me the answer. This is a time. This is an independent question of thread. Thread के ऊपर नहीं है ये question, लेकिन basically you can work out still. You can still work out. Let the time taken to switch between user and kernel modes of execution be T1. देखिएगा, this is user mode and this is kernel mode. Time to shift from mode 1 user mode to kernel mode is T1, right? While the time taken to switch between two processes be T2. Like if this is one process P1, this is another process P2. When I want to shift from one process to another process, this time taken is T2. So what should be the legal relationship between T1 and T2? Meaning, is T1 equal to T2, or T2 is greater than T1, or T1 is greater than T2? What is the correct answer? Context switching time between two processes always need mode shifting. That means I will write like this: T2 will includes T1. That means अगर आप exactly लिखोगे T2 is nothing but T1 plus time to load and save process control blocks. So naturally T2 is greater than T1. T2 is greater than T1. So therefore the correct answer is C. The correct answer is C. Reason is like this. The justification is like this. Chaliye. Next. Tell me the answer for this. Tell me the answer for this. Rohit Roy, welcome. Shravan Kumar. Come on, answer this question. Okay. Consider the following statements about user level threads and kernel level threads. Which one of the following statements is or are true? मतलब वही हुआ. This is MSQ. This is MSQ. चलिए start करेंगे. Context switch time is longer for kernel level threads than for user level threads. Context switching time is longer for kernel level threads. Yes, right, because I have to shift from mode 1 to mode 2. So therefore, this is true. User level thread do not need any hardware support. This is also true. Related kernel level threads can be scheduled on different processors in a multi-processor system. Definitely true. Blocking one kernel level thread blocks all related threads. These false. This happens for user level threads, not for kernel level threads. So therefore, the correct answer happens to be, right, A, B and C. A, B and C. A, B and C are correct. Very good. Many people gave correct answer. Next. इसका आंसर बता दीजिएगा. Slight variation again. Which one of the following is or are shared by the threads of the same process? Sharing पूछ रहा है बच्चों. Sharing is or are shared. MSQ. MSQ. Come on. Warm up questions. I'm saying this is MSQ. So be careful in selecting the choices, boys and girls. Be careful in selecting the choices. Stack are shared, whereas stack is not shared. Address space is shared. File descriptor table is shared, right? He is saying are shared, right? So therefore, this is shared. Message queue is also shared. Very correct. Many people again gave the correct answer. B, C, D. B, C, D. Message queues are also shared. This is IPC mechanism. This is IPC mechanism. IPC mechanisms will always be shared. बात रिमेंबर करने की यहां पर यह है बच्चों, नॉट ओनली आईपीसी मैकेनिज्म इज शेयर्ड बिटवीन थ्रेड बट आल्सो बिटवीन प्रोसेसेस. जब आप फोक मैकेनिज्म से प्रोसेस को क्रिएट करोगे, ऑल आईपीसी मैकेनिज्म्स आर शेयर्ड. रिमेंबर दिस पॉइंट. ऑप्शन सी इज फाइल डिस्क्रिप्टर टेबल. फाइल्स आर शेयर्ड बिटवीन द थ्रेड्स. File descriptor table will contain information about all open files by the process. So file descriptor table is shared. Yeah, message queue is an IPC mechanism. It's a queue that allows processes to communicate. It's a queue like FIFO queue that can be shared between the processes or between the threads like this. ऐसे रहेगी. File descriptor table contains information about all the open files. जितने भी फाइल्स प्रोसेस ने ओपन किए हैं उसका इंफॉर्मेशन फाइल डिस्क्रिप्टर टेबल में रहेगा. इट विल बी शेयर्ड बाय ऑल द प्रोसेसेस. ठीक है. यस. अभय सिंह इज आस्किंग फोर्क में क्या शेयर होता है? फोर्क में नथिंग विल बी शेयर्ड एक्सेप्ट आईपीसी मैकेनिज्म्स. व्हेन यू क्रिएट अ प्रोसेस विथ फोर्क, स्टैक इज नॉट शेयर्ड, हीप इज नॉट शेयर्ड. एवरी प्रोसेस विल हैव इट्स ओन एड्रेस स्पेस. व्हाट इज शेयर्ड इज आईपीसी मैकेनिज्म्स. What is shared is IPC mechanism. Answer for Abhay Singh question. चलिए नेक्स्ट. इसका आंसर दीजिएगा प्लीज. आंसर बता दीजिएगा. I'll just come within 2 minutes. Carefully tell me the answer. चलिए बच्चों, इसका आंसर बता दीजिए क्या है। यस, गुड इवनिंग निशु कुमार। Amol, paid batch will be launched very soon. I think in the first week of February. Very soon we are going to launch the paid batch on an academy. Just have some patience. चलिए, consider the following statements with respect to user and kernel level threads. Context which is faster with user supported threads. This is true. For user level threads, a system call can block the entire process. True. Kernel supported threads can be scheduled independently. True. User level threads are transparent to kernel. All are true. All are true. ठीक है. So therefore 1, 2, 3 and 4 option D. Option D is correct. बिल्कुल सही. See, there was no time. That is why parallelly we are running mathematics class of Rahul and myself. There is no time. आप जो यहाँ का अगर छूट गया हो तो वहां पे रिकॉर्डेड देख लीजिएगा, राइट, या वहां का छूट गया तो रिकॉर्डेड देख लीजिएगा. ठीक है, काइंडली मैनेज इट. तो चलो बच्चों, अब नेक्स्ट स्टार्ट करेंगे सिंक्रोनाइजेशन पर. सिंक्रोनाइजेशन का एक थोड़ा ब्रीफ डिस्कशन देखेंगे, फिर कुछ क्वेश्चंस ले लेंगे, फिर उसके बाद मोर इंपॉर्टेंटली डेडलॉक से प्रॉब्लम्स काफी सॉल्व करने की कोशिश करेंगे. ठीक है, फिर उसके बाद मेन फोकस होगा मेमोरी मैनेजमेंट पर. तो सबसे पहले यहां पर बोलेंगे हम, लैक ऑफ सिंक्रोनाइजेशन इन आईपीसी एनवायरनमेंट में लीड टू प्रॉब्लम्स ऑफ inconsistency या sometime data loss and sometime deadlocks. These are the problems that arise due to lack of synchronization among communicating processes. Shravan Kumar, we have already completed CPU scheduling in the last session. चलिए, so in this way we classify the processes or types of synchronization as competitive or cooperative. Competitive का मतलब there is a contention between the processes. Processes are trying to contend for the accessibility of shared systems. अगर आपने नेटवर्क्स पढ़ा हो वहां पर भी आप जनरली बोलते हैं कॉम्पिटिटिव सिस्टम्स जो है ना, कॉम्पिटिटिव सिस्टम्स या फिर contention systems. Can you give an example of a contention system analogously in networks? Networks में contention systems या competitive systems का example क्या है, बोलिएगा. contention systems का networks में क्या example है, बोलिएगा. Amol, you just concentrate on the lecture. Why do you worry about all those things? खड़े रहकर पढ़ाएंगे, बैठ कर पढ़ाएंगे, लेट कर पढ़ाएंगे, कैसे पढ़ाएंगे, इससे क्या फर्क पड़ेगा आपको? पढ़ाएंगे तो खलील सर पढ़ाएंगे, अंकित सर पढ़ाएंगे, राहुल सर पढ़ाएंगे, मल्लेशम पढ़ाएंगे, सभी पढ़ाएंगे. Amol, come on, don't concentrate on those aspects. Shrishti Chaudhary is correct, right? Yes, this is nothing but carrier sense multiple access, CSMA, or Aloha systems. The example of that is Aloha system or contention systems. बात तो सही है ना भाई बैठ के पढ़ाएं या खड़े के पढ़ाएं, इससे आपको क्या फर्क पड़ने वाला है? पढ़ाएं तो हम पढ़ाएंगे ना, ठीक है. खलील सर की जगह कोई दूसरा पढ़ा रहा है तो ठीक है, आपकी बात सही है. दैट डिपेंड्स ऑन द प्लेटफॉर्म की होगी, देखेंगे जो भी सिस्टम होगा अवेलेबल वो फॉलो करेंगे. चलिए ठीक है, CSMA कैरियर सेंस मल्टीपल एक्सेस या फिर अलोहा सिस्टम जो आपने पढ़ा हो, दैट इज एन एग्जांपल ऑफ कंटेंशन सिस्टम्स. वहां पर भी वही कॉन्सेप्ट है, राइट? यू विल हैव द प्रॉब्लम ऑफ लॉस ऑफ करप्शन ऑफ डेटा when 2 or more stations are simultaneously trying to access the channel, leading to collisions, and that is nothing but contention cooperation. So that also lead to loss of data, that also lead to inconsistency, same problem होगा. So that is also an example of this. तो यहां पर जो carrier sense multiple access में जो है same problem, critical section, your channel is your critical section, right? Stations या machines are your processes, are your processes. That is a very close analogous example of contention systems जो operating system और networks में together as an analogy है, as an analogy. So synchronization, what is needed is basically of two types: competitive synchronization, cooperative synchronization. Competition synchronization में मतलब यह है कि processes are contending for the accessibility of critical section or critical resources. Cooperation मतलब processes are trying to basically get affected by each other. Execution of one process will affect the other process. ये है concept. Then इसके बाद हमने problem define किया, some terminology define की with regard to defining what is called critical section, right? Then what we call it as non-critical section. And then we also defined something called race conditions. A situation where processes are racing for the accessibility of critical section, or a situation where basically like multiple processes are contending for the accessibility of a shared resource, and the final result will depend on the order in which the processes are updating or manipulating the shared resources. That is called race condition. तो कोई भी environment में critical section हो और race condition हो और preemption possible हो, there is every possibility, there is every liability that we can enter into a problem. There can be a potential problem of synchronization. मतलब या तो inconsistency होगी या data loss होगा या फिर deadlocks भी हो सकता है. तो मतलब ये हुआ कि if you don't want any of these problems to happen, अगर आप इसे diagrammatically समझने की कोशिश करो, so this is my critical section, and here we have processes, P1, P2, P3, critical section, all trying to enter critical section, So if I don't have a proper coordinated access to critical section, then every time I am going to encounter a problem. तो अगर आप problem नहीं चाह रहे हो, then that means the processes should not be allowed to access critical section together at the same time. That means in between the processes and critical section, I should have this security guard. Called synchronization mechanism. Software chip synchronization mechanism is needed between the processes and critical section, essentially protecting your critical section. उसी तरह जैसा आपके CSA में contention systems में carrier sense multiple access protocols में you need to resolve it either through distributed approach or centralized approach, right? Or you can follow a collision free concept, some sort of mechanism. उसी तरह यहाँ पर भी आपके some protocols चाहिए, some synchronization protocols. So this synchronization tool or synchronization mechanism हमने पढ़ा has two parts. One is called entry section, the other is called exit section, and that is why this problem now, ये जो problem है जो हम solve करने की कोशिश कर रहे हैं, ये problem का नाम दिया गया है critical section problem. Solving the critical section problem means developing the solution for it. The solution for it is called synchronization mechanism. जो solution है इसका. अगर आप टोटल मॉडल समझो सिंक्रोनाइजेशन मैकेनिज्म का, टोटल कॉन्सेप्ट समझने की कोशिश करो, देन व्हाट आई से इज इट विल बी समथिंग लाइक दिस. These your critical section will be supported or protected by entry section and controlled by exit section, and here you have multiple processes. Here you have the actual model or the actual concept goes like this. These critical section, these entry section is exit section. So this is the model or the architecture of critical section problem. और हमने कहा if you remember that every problem will have its own requirements. हर problem के अपने requirements होंगे, उसी तरह critical section के भी requirements है, critical section problem के भी requirements है. Quickly tell me in the chat box बच्चों, what are the requirements of critical section problem to be satisfied by any synchronization mechanism? Come on, tell me. Write down in the chat box and let me know. What are the synchronization requirements? Requirements of the critical section problem to be satisfied by any synchronization mechanism. Come on, tell me. What are the requirements? Yes. The requirements are: number 1, mutual exclusion. Number 2, progress. Number 3, bounded weight. 3 conditions. Mutual exclusion ensure that if one process is present in critical section, no other process should be allowed. Progress ensure that no process running outside the critical section should prevent the other process from entering critical section. Nobody has got the right to block the progress of others. Eventually, हम ये कहना चाह रहे हैं कि अगर क्रिटिकल सेक्शन फ्री हो और कोई प्रोसेस एंटर होना चाह रहा है तो वो प्रोसेस एंटर होना चाहिए. Nobody should block it. Nobody should prevent it from entering critical section. ये है progress. Generally, people get confused with progress. Eventually, some process should enter critical section when critical section is free. If solution is not ensuring that, then progress is dissatisfied. So that is about progress. Deadlock भी जब होगा ना, प्रोग्रेस डिससैटिस्फाइड होगी, क्योंकि अल्टीमेटली जब डेडलॉक होगा तो एक प्रोसेस दूसरे प्रोसेस को ब्लॉक करेगा और दूसरा पहले वाले को ब्लॉक करेगा. सो दैट इज द कंडीशन ऑफ प्रोग्रेस. बाउंडेड वेट. लेकिन एक बात यहां पर याद रखने की है, इफ क्रिटिकल सेक्शन इज इन यूज देन नोबडी शुड एंटर. दैट इज नॉट प्रोग्रेस. राइट? क्रिटिकल सेक्शन शुड बी फ्री फॉर द प्रोग्रेस टू बी सैटिस्फाइड. नेक्स्ट इज बाउंडेड वेट. बाउंडेड वेट का मतलब यह है कि देयर शुड बी ए लिमिट, देयर शुड बी ए बाउंड ऑन द नंबर ऑफ टाइम्स ए प्रोसेस is allowed to enter critical section before other process request is granted. मतलब simple points में ये है कि if multiple processes are interested in entering critical section, आप एक fair share guarantee करना होगा. Fair share का मतलब if P1 enter, P2, P3 cannot, then after P1 comes out, then P2 should enter if it is interested. Then after P2 comes out, P3 should enter. अगर आप ये fair share guarantee नहीं करोगे, then that means it will lead to starvation. So dissatisfaction of bounded waiting may lead to starvation. Dissatisfaction of progress may lead to starvation. So that is why we generally say that mutual exclusion is the main condition. This is the primary condition to be fulfilled. अगर mutual exclusion violate हो रहा हो तो आपको शायद problem होगा inconsistency का data loss का. लेकिन bounded waiting और progress के dissatisfy होने से, right, because of the dissatisfaction of bounded waiting or progress, right, because of dissatisfaction of bounded waiting and progress, we may lead to not inconsistency or data loss but starvation hoga. So that is the meaning of this point, right? So that is the 3 requirements. So if these 3 requirements are fulfilled, then we say that our solution is correct, our mechanism is correct. Synchronization mechanism will fulfill all the conditions, and hence we will not have any problem of synchronization like inconsistency or data loss or deadlock. तो ये satisfy करने के लिए we have basically categorized all synchronization mechanisms into 2 types. Synchronization mechanisms are classified into 2 types. चलिए chat box में लिख के बताइए, देखेंगे आप remember कर रहे हो या नहीं. Come on, boys and girls, please tell me. Synchronization mechanisms are classified into 2 types. Tell me the classification. Yes, that's right. One is busy waiting. The other is non-busy waiting. Non-busy waiting का मतलब यह है कि it is also called blocking. Busy waiting is sometimes also called spin lock solutions. Busy waiting is generally implemented using loops. This is implemented using if then else. right? Further, I would like to tell you that these two together are classified into three types. One is called the software solutions, the other is hardware solutions, and the other third one is OS based as an operating system resource. Like for example, under software solution category mean they are all implementable at user mode. Hardware solution means architectural specific. Architectural support is needed for them through some special hardware instructions. Examples of software solutions include lock variables, lock, strict alternation, Third is Peterson solution. And a variation of Peterson solution is Decker algorithm. Under hardware category, we have TSL, we have swap, we have compare and swap, CAS, three solutions, compare and swap. OS based mein most important one is sleep and wake up. The most important one, semaphore. And last is through operating system programming language support, monitor. So these are the mechanisms. तो बच्चों ये बहुत important है कि all these mechanisms which I have written here, you should have extreme clarity. With regard to all of them. Quickly एक solution लेकर orally discuss कर लेंगे यहाँ पर, so that it become reminders to you. Number one, come on, participate in the discussion. Lock variable does not guarantee mutual exclusion, because if a process get preempted before updating lock, then basically I may encounter a problem. Mutual exclusion will not be guaranteed always with lock variable. Progress is guaranteed. Bounded waiting is again not guaranteed with lock variable. Multi-process solution, it can be used by more than two processes. Next, strict alternation. Tell me in the chat box, strict alternation, guarantee mutual exclusion or not, guarantee progress or not, guarantee bounded waiting or not. Please write down in the chat box and let me check. Give me the information. Strict alternation. Does it guarantee mutual exclusion or not, progress or not, bounded waiting or not? बोलिएगा. Tell about strict alternation. Come on. Come on. Strict alternation guarantee mutual exclusion, does not guarantee progress and guarantee bounded waiting. You have to remember like this, because sometime 1 mark questions are asked, and for which you have to remember for every mechanism what is guaranteed, what is not guaranteed. ठीक है. So mutual, again I am repeating, strict alternation guarantee mutual exclusion, does not guarantee progress but guarantee bounded waiting. Yes, that is correct. Guarantee bounded waiting, satisfy bounded waiting, but it is limited to work with two processes. Peterson solution guarantee all the requirements, guarantee all the conditions. Lekin it is limited to work with only two processes. And secondly, it is a busy waiting solution. It leads to wastage of CPU time. Thirdly, Peterson solution और Decker's algorithm का दोनों का और एक common problem है. It may not work on all processors or architectures. May not work, यहाँ पर लिख रहा हूं मैं. May not work with all processors or architectures or modern compilers. जहां पर statements का order change हो सकता है. Ordering of statements can get changed in the modern architectures or compilers, then Peterson solution may fail to guarantee mutual exclusion. इसका मैंने प्रूफ किया था जनरली इन द रिवीजन कोर्स, तो अगर आपने रिवीजन कोर्स का एक्सेस है तो आप देख सकते हो. सो दैट इज यस, इट इज लाइक cricket match toss example, Peterson solution. To overcome these problems, we have hardware solution. Hardware solution का मतलब architecture will provide some special instructions which are atomic instructions. So all these are based on atomic instructions. Atomic instructions. And these are all the variations of these three are all the variations of what we call lock variable based solutions. TSL, ya swap, ya compare and swap. All these are based on extensions of lock variable. And they basically guarantee mutual exclusion, guarantee progress, and also bounded waiting. They are multi-process solution. They are multi-process solution. They are all multi-process solution, right? So that is the discussion that we had with regard to the hardware mechanism or special hardware instructions, the atomic instruction. Problem यही है कि basically they are busy waiting, that will lead to wastage of time. And thirdly, all correct busy waiting mechanisms, all correct busy waiting, whether it is software or hardware, will suffer from a problem which is generally called priority inversion problem. If you remember, priority inversion problem. I anticipate that maybe in some gate paper you may expect a question on priority inversion. तो बच्चों गौर से याद रख लीजिएगा. Harsh Vishwakarma, I told you already in the class, if you have listened to my classes, with the additional logic which is discussed in the Galvin textbook, if you add it, guarantee bounded waiting. So all correct busy waiting mechanisms suffer from a problem called priority inversion, which will lead to deadlock or live lock, ठीक है ना. Conceptually, live lock is similar to deadlock, except that the states of the process are different. In deadlock, the states of the process are always blocked. In live lock, the states of the process may not be blocked. Progress may be there in live lock, but eventually the situation will be similar to deadlock. Farhan Khan, with additional logic, repeatedly I am telling, with additional logic, TSL guarantee bounded waiting, TSL set test and swap, swap instruction, and then compare and swap, they are all guaranteeing bounded waiting. Yes. Then the solution to this priority inversion problem, to prevent deadlock, to prevent live lock, the solution to priority inversion problem is called priority inheritance protocol. Priority inheritance protocol. Priority inheritance में क्या होगा? We are going to inherit the priority. You are going to exchange the priority of the processes, and therefore it will overcome the problem. It will overcome the problem. So this is a brief discussion with regard to software and hardware. अब रही बात operating system based solution, sleep and wake up. अगर आप sleep and wake up, you take it in a standalone fashion, then again it will lead to deadlock. I have demonstrated that in the example of producer-consumer problem. In the example of producer-consumer problem, we have seen how sleep and wake up may potentially lead to deadlock. Abhay Singh, live lock, how to identify? I mean, by analyzing the code, you can identify. जो मैं priority inversion का problem explain किया था, वहां पर live lock है. One process is running on CPU, another process is there in the ready queue. They are waiting for each other, right? They are waiting for each other. That is a live lock situation. Yes, welcome, Saini. Come on. Next रही बात semaphore. Next आ जाएंगे, थोड़ा डिस्कशन कर लेंगे. Quick discussion on semaphores. Start topic. मैं बच्चों से अपील ये कर रहा हूं कि एक बार ये जो लास्ट 10 days है या लास्ट 8 days है, I would request everybody to revise semaphore compulsory. Some of the important aspects I will tell now. इसके अलावा डिटेल एनालिसिस, डिटेल रिवीजन कीजिएगा ऑन सेमाफोर, बिकॉज देयर इज एवरी लाइक्लीहुड दैट इन एवरी ईयर गेट पेपर यू विल एक्सपेक्ट अ क्वेश्चन ऑन सेमाफोर. और सेमाफोर के लिए आपको सेमाफोर ऑपरेशंस, टाइप्स ऑफ सेमाफोर्स आना बहुत ज़रूरी है, ठीक है ना. तो एक बार बिल्कुल एक या दो दिन पहले सेमाफोर का अच्छा प्रिपरेशन करके जाइएगा, अच्छा रिवीजन करके जाइएगा. सो सेमाफोर इज एन ऑपरेटिंग सिस्टम रिसोर्स. Operating system resource. It is a variable of ADT type that takes only integer values. Based on the value semaphore takes on, we classify semaphore into two types. One is called counting or general semaphores. Counting or general semaphores. And the other is binary semaphores. Binary semaphores. Counting semaphore can count any negative value to positive value. This can take only two values, 0 or 1. 0 or 1. And being an abstract data type, semaphore support two operations. One is called down, the other is called up. Down is also called P, up is also called V. Down is also called wait, and up is also called signal. Right? Down, up, P or V, wait or signal. Some people even call signal operation as release. Now observe, we need to really build up understanding as to what happens when a process perform down operation and what happens when a process perform up operation. यहाँ पर summarizingly आपको mention कर दूं, the result of down operation, the result of down operation is either the process is successful in performing down operation or it is unsuccessful in performing down operation. Unsuccessful means the process will get blocked. If it is successful means the process will return from down. And another important point to keep in mind is that the semaphore operations of down and up are atomic. Atomic का मतलब they are non-preemptive. Now we need to understand when do process get blocked while performing down operation on counting semaphore and on binary semaphore. एक बार understand कर लेंगे orally, ठीक है ना? सुनिएगा. A process performing down operation on counting semaphore will decrement the current value of semaphore by 1. Again I repeat, process performing down operation on counting semaphore will decrement the current value of semaphore by 1. After decrementation, if the resultant value is negative, then we say the process is unsuccessful in performing down and will get blocked. नहीं, अगर negative ना हो, the value of the resultant value of the semaphore is either greater than or equal to 0 after decrementation, then the process is successful in performing down. Right? अगर negative हो रही है value, तो then it is unsuccessful. अगर negative नहीं हो रही है value, it is either greater than or equal to 0, then it is successful for counting semaphore. Binary semaphore में क्या होगा? If the current value of semaphore is 0, 0 down is 0, blocked, unsuccess. 1 down is 0, success. ये बात याद रखिएगा. 1 down is 0, success. 0 down is 0, binary semaphore, unsuccess. उसी तरह up operation. जब process up operation perform करेगा counting semaphore पर, then it will increment the current value of semaphore by 1. And after incrementation, if the resultant value is less than or equal to 0, then it will wake up. That means there are block processes. It will wake up one of the block process. अगर greater than 0 है up operation से, then there are no block process. I don't have to wake up anybody. उसी तरह up operation on binary semaphore, right? 0 up becomes 0 if the queue is not empty. 0 up will become 1 if the queue is empty. 1 up is always 1 because 1 means critical section is free. यह है summarized discussion with regard to operations on binary and counting semaphore. चलिए एक simple example लेके before I take up the practice questions, I will take one simple example. And see whether you can answer it. In a certain application, the value of semaphore, let us say, is 10. And then we complete the following operations on it. 15 down, 1 up, 20 down, 5 up, 6 down, 3 up. What is the current value of semaphore now? ये popular question है इस तरह का. Tell me the answer for this question, boys and girls. तारंग कुमार सिंह. we have left that organization and joined, the whole computer science team have left that organization and joined PW, Unacademy. चलिए इसका आंसर देखेंगे बच्चों. Value of semaphore is 10, performing 15 down will make it to -5. Make it to -5. Next, 1 up will increment by 1, so therefore -4. 20 down, all 20 will get blocked, -24. 5 up operations, increment by 5, -19. 6 down, all 6 will get blocked, so -25. 3 up, 3 increment, so therefore -22. बिल्कुल सही जवाब, कई बच्चों ने सही आंसर दिया. -22 is the final answer. -22 is the final answer. ये सही आंसर है. That means there are 22 block processes right now. चलिए नेक्स्ट है बच्चों, विथ रिगार्ड टू एप्लीकेशंस ऑफ सेमाफोर. मॉनिटर्स भी एक इंपॉर्टेंट है, आप देख लीजिएगा, ज्यादा उतना कॉम्प्लेक्सिटी नहीं है उसमें, लेकिन एप्लीकेशंस ऑफ सेमाफोर की अगर बात होगी, एप्लीकेशंस ऑफ सेमाफोर की अगर बात होगी, दैट इज इन द इंप्लीमेंटेशन ऑफ क्लासिकल आईपीसी प्रॉब्लम्स. आई वांट एवरीबडी टू बी वेल फेमिलियर विद द फॉलोइंग क्लासिकल आईपीसी प्रॉब्लम्स. काफी क्वेश्चंस आ चुके हैं प्रीवियस पेपर में और आगे भी आप एक्सपेक्ट कर सकते हो. सो बी वेरी क्लियर. इंप्लीमेंटेशन ऑफ प्रोड्यूसर कंज्यूमर प्रॉब्लम यूजिंग semaphores. Nishu Kumar, please listen to me. I am telling you, and other people also who are raising the same doubt, please listen to me, that TSL and swap instruction, if I implement it with the code which I gave in the class, it does not guarantee bounded waiting. In the textbook of Gallin, मैंने कहा कि if you incorporate that additional logic in the code, then it will guarantee bounded waiting. तो हम ये assume करेंगे by default it will be with additional logic, so therefore it guarantee bounded waiting. Therefore it guarantee bounded waiting. ठीक है, चलिए क्विकली ये पूरे क्वेश्चंस हम एक बार रिवाइज करेंगे. प्रोड्यूसर कंज्यूमर प्रॉब्लम. देयर आर 2 काइंड्स ऑफ प्रोसेसेस, one by name producer, another by name consumer. Reader writer भी explain कर दूंगा. Please follow me. Niels Bohr, you can watch live now today. ये जो interactive session है इसमें doubts भी clear कीजिएगा और मेरे important points आपके कुछ काम आएंगे. So please understand. Watch the video. Producer consumer. There are 2 processes, producer consumer. Producer and consumer runs infinitely. We have a shared buffer, limited size buffer, bounded buffer having some slots. Producer produces an item, makes an attempt to place the item in the buffer. मतलब वो check करेगा buffer is full or not. If buffer is full, it will wait. If buffer is not full, it will produce and place the item. Otherwise, consumer will check whether buffer is empty or not. If buffer is empty, it will wait. If buffer is not empty, it will consume the item, process it and go for next cycle, next consumption. This is what is called producer consumer problem. अगर पूरा solution को incorrect implement करोगे तो then we have inconsistency, we may have deadlock between producer consumer. ये हमने अपने क्लास में detailed solution में explain किया था. Second problem है reader writer. Like producer consumer, there is a shared database between reader and writer. ये एक database है. So here I have reader processes R1, R2, R3, so on, Rn. Here we have writer processes W1, W2, W3, Wm. Multiple readers, multiple writers. Condition ये है कि multiple readers can exist in database, but at a time only one writer should be there. I cannot have multiple writers in the database. क्योंकि write operation सिर्फ एक ही करोगे आप, एक ही process से करोगे. If 2 or more writers are trying to update database together at the same time, it will lead to inconsistency. So therefore, database become critical section between reader and writer. If reader is there, writer should not be allowed. If writer is there, reader should not be allowed. But if one reader enters, all other readers can enter. ये problem का definition है first reader writer. एक reader अगर successfully enter हो जाएगा database में, you can permit other readers to enter database. That is first reader writer. ठीक है. So that is the concept of reader writer. इसका implementation हमने देखा था using semaphores. How we can implement this using semaphore? I have done that. Very good. चलिए, third problem है again a dining philosopher that become the foundation for deadlocks. Dining philosophers that become the foundation for deadlock. Generally defined for n philosophers, say 5 philosophers. In between them there are forks. Philosophers become hungry, will try to take the fork. Philosophers become hungry, they try to take the fork. Problem कब होगा? When one philosopher successfully takes up one and wait for other. Then potentially we can encounter a deadlock problem. Deadlock. So using semaphore, the thing is, how are we going to control deadlock? How are we going to prevent deadlock using semaphore? That is the main intention of solving dining philosophers problem. तो देखिएगा बच्चों, प्रोड्यूसर कंज्यूमर में इनकंसिस्टेंसी भी हो सकती है, डेडलॉक भी हो सकता है. रीडर्स राइटर्स प्रॉब्लम में इनकंसिस्टेंसी हो सकता है, डेटा लॉस हो सकता है, एंड डाइनिंग फिलोसोफर में डेडलॉक होगा. यस, डाइनिंग फिलोसोफर में डेडलॉक प्रॉब्लम होगा. तो हाउ टू अवॉइड डेडलॉक वो हमने डिस्कस किया था यूजिंग मॉनिटर्स एंड यूजिंग सेमाफोर्स, बोथ ऑफ देम. तो चलिए अब बच्चों, आप कुछ क्विकली प्रॉब्लम्स लेंगे. दिस इज द स्लाइड्स फॉर यू फॉर योर नोट्स. You can check them later point of time, right? This will be given to you. I will share it in the group also. The complete PDF I will share it in the group. Solution भी describe है यहाँ पर, देखिएगा. You can read it at another point of time. So now I will take up some practice questions. Come on, tell me the answer for this. These get 2023 question. Rakesh Joshi, bakery algorithm is for multi-process solution. It will require a lot of time to make an analysis of it. Right now in this session it may not be meaningful. हाँ, अनअकैडमी पर पेड बैच में मैं बेकरी एल्गोरिथम भी डिस्कस करूंगा, होपफुली. This get 2023 question. Come on, tell me the answer for this. Yes, I will provide the group link, Satish Kumar. Don't worry. I will provide the Telegram channel group link. You can basically access that group and get the material. Here I will write it down. T.me. Let me check. This is my Telegram channel. You can basically access it. SK Islam. This is not the correct platform to discuss about that. You don't worry about and don't try to spam the chat box. Whatever has happened for betterment. So we don't have to discuss about that. चलिए बच्चों, इसका आंसर बताइए. Consider the functions INCR and decrement, increment, decrement. Weight on S, x equal to x plus 1, signal on S, weight on S, x equal to x minus 1, signal. There are 5 threads, each invoking increment once. 5 threads, 5 times we are executing this. 5 threads are executing this. And 3 threads each involving decrement once, right? So 3 times decrement function on the same shared variable x. X यहाँ पर भी है, x यहाँ पर भी है. The initial value of x is 10. देखिएगा, the variable initial value of x is 10. X is 10. चलिए देखेंगे. Suppose there are 2 implementations of the semaphore S as follows. In the first implementation, implementation 1. S is a binary semaphore initialized to 1. Agar S is initialized to 1, listen to me bachcho. I will write like this. First implementation, binary semaphore S initialized to 1. Binary semaphore S initialized to 1. Right? Binary semaphore S is initialized to 1. then question is V, and in the second implementation S is a counting semaphore initialized to 2. ऐसे questions important है बच्चों. Let V1, V2 be the values of X at the end of execution of all the threads with implementation I1 and I2 respectively. Then question is, which one of the following corresponds to minimum possible values of V1 and V2? Minimum possible values of X क्या हो सकती है? Minimum possible value of X. जगह binary semaphore होगा तो this will be executing like atomic type execute होगा. मतलब अगर if this is successful, this won't be successful. If this is successful, this won't be successful. तो मतलब straight away ये है, on the initial value of semaphore X equal to 10, you are performing 5 increment operations, so value become 15. 3 decrement operation, value become 12. ठीक है ना? With binary semaphore, the final value in any order you execute will always be 12. अगर आप बोलोगे सर मैं पहले यहां एग्जीक्यूट करूंगा, so 10 से 3 टाइम डिक्रीमेंट बिकम 7 से 5 टाइम इंक्रीमेंट करोगे तो 12 बनेगी वैल्यू हमेशा. So whether you increment first or decrement first, the final consistent value of X will always be 12. ये बात समझ में आ गई सभी को? तो मतलब अगर आप चॉइसेस देखो तो 12 के 2 चॉइसेस है, 12 7, 12 8. तो मतलब this is wrong, either it has to be C or D. तो चलिए अब बाइनरी काउंटिंग सेमाफोर से इंप्लीमेंट करेंगे. सेकंड, काउंटिंग सेमाफोर S इनिशियलाइज्ड टू 2. तो क्या मुझे कोई बताएगा what can be the minimum possible value of X? What can be the minimum possible value of X? ठीक है, what can be the minimum possible value of X? चलिए बोलेगा बच्चे. मिनिमम आंसर करने के लिए you can basically go like this. You allow the first process. चलिए मैं यहां पर कर रहा हूं, सुनिएगा बच्चों कैसे करेंगे. X is equal to 10. I start with the threads that perform decrement operation. So first time decrement करेंगे, value बनेगी 9. I perform second decrementation, the value become 8. I perform third decrementation, right? The value has not, we have read the value of X into register by third thread. The value has become 7. We have read 8, decremented by 1, 7. लेकिन value of semaphore was 2. So because of the first decrement, it has become 1, right? Because by the third thread, it has become 1. Semaphore की value 1 है. Semaphore की value 1 रहने से क्या होगा? We can perform this increment operation. Successfully. So right now the value is 8. I perform 5 increments, so value become 13. लेकिन this thread is still pending. The last thread of the decrement is still pending to update its value back into X. So therefore, when it execute, it will update 7 here. It changes from 13 to 7, mean the final value can be 7. If you say 8, then it is wrong. So final value can be 7. So minimum value with first implementation is 12, and minimum value with second implementation is 30. Is 7. So therefore, the correct answer happens to be C. Many people gave correct answer. बिल्कुल सही. चलिए नेक्स्ट और एक क्वेश्चन लेंगे. इसका आंसर बता दीजिएगा प्लीज. वेरी सिंपल क्वेश्चन. बहुत सिंपल क्वेश्चन है. Come on, tell me the answer for this. Come on, tell me the answer for this. Consider the following threads T1, T2 and T3 executing on a single process synchronized using 3 binary semaphores S1, S2 and S3 operated upon using standard wait and signal operations. The threads can be context switch in any order, means I can start from T1, T2, T3 in any order. I can have context switching. So he say that what should be the initial value of semaphores would print the sequence BC. मतलब अगर आउटपुट आपको आना है B से, wait on S3 should be 0, S1 should be 1, S2 should be 0. ठीक है, very simple. Nishu Kumar, please follow here. Because if you start with T1, the output should not start with C, output should start with B. तो मतलब this, even if you perform down operation, this should be unsuccessful. This should also be unsuccessful because you can start with either T1 or T2 or T3. तो जो भी ऑर्डर में आप स्टार्ट करोगे, if you start with T1 it will get blocked, if you start with T3 it will get blocked, then compulsory this will be successful. So first I will output B. इसके बाद it is performing up operation on S3. Where is S3? S3 is here. So therefore the next output will come C. This is waking up S2. S2 is here. So the output will come A. Again it will wake up S1. So again B. So it will repeat like BCA, BCA, BCA. So therefore the answer is S1 is 1, S2 is 0, S3 is 0. S1 is 1, S2 is 0, S3 is 0. Correct option is C. बहुत सिंपल है, बहुत सिंपल क्वेश्चन। चलिए, ये एक इंपॉर्टेंट क्वेश्चन है, इसे रीड कीजिएगा। प्रीवियस ईयर क्वेश्चन है, आंसर बता दीजिएगा प्लीज। टेल मी द आंसर फॉर दिस इज एन इंपॉर्टेंट क्वेश्चन। जनरली पीपल गेट कंफ्यूज हियर। चलिए नेक्स्ट देखेंगे। Where S is a semaphore initialized to 5, but the value of 5, S is 5. Counter is a shared variable initialized to 0. Assume that the increment operation in line 7 is not atomic. This is not atomic. मतलब the statement stands for counter is equal to counter plus 1. There can be preemption in between. Why is it not visible? Harshal Puranik, why is it not visible? Code is visible. चलिए अब क्वेश्चन आएंगे, अब क्वेश्चन देखेंगे क्या है। तो wait on S, counter is incremented by 1, signal on S. First question, if 5 threads execute the function parop concurrently, there are 5 processes that are executing concurrently. Which of the following behavior is or are possible? MSQ question है, MSQ. Which of them is possible or not possible? You have to answer. Come on, boys and girls, please tell me. Please tell me. What can be the final possible values of mic issue? Needs worry. Is there any problem with audibility? Audibility का कोई problem है क्या? Come on, boys and girls, am I audible? Okay, ठीक है, very good. चलिए, what is answer? अब देखेंगे। तो सबसे पहले हमें ये अंडरस्टैंड करना है, the value of a counter is 5 after all threads successfully complete the execution. क्या final value of thread 5 हो सकती है? Is it possible? We have to analyze. So see the code. If you execute the threads in any order, कोई भी order में आप execute करो, is it possible to get the final value of counter as 5? हाँ, हो सकती है। कैसे? If you allow the threads to execute one after totally, पहले thread start करेंगे आप, wait on S success, counter is incremented to 1, signal on S, signals, thread 1 is over. फिर उसके बाद आप thread 2 रन करो, फिर thread 3 रन करो, फिर thread 4, thread 5, counter की वैल्यू 5 होगी। तो sequentially अगर आप execute करोगे, the final value of counter can be 5. This is possible. Next, the value of counter is 1. The value of counter is 1 after all threads successfully complete the execution of parop. क्या 1 भी हो सकती है with preemptive execution? हाँ, हो सकती है 1 भी। क्यों? If you start with thread 1, listen to me. If you start with thread 1, it has loaded the value of counter into register and incremented the register by 1. So therefore, register has become 1. Before storing this register into counter, you preempt thread 1. Thread 1 got preempted. इसके बाद आप क्या कीजिएगा? You run thread 2 completed, thread 3 completed, thread 4 completed, thread 5 completed. तो counter की value 4 होगी. Counter. So thread 1 got preempted before updating. Thread 2, thread 3, thread 4, thread 5 completed. इसके बाद last में thread 1 will update this value, so it changes from 4 to 1. It changes from 4 to 1. So therefore, the correct this is also possible. This is also possible. The value of counter is 0. 0 impossible है क्योंकि इंक्रीमेंट तो होगा रजिस्टर जब इंक्रीमेंट होगा तो मिनिमम इंक्रीमेंट 1 होगा, तो डेफिनेटली ये पॉसिबल नहीं है. There is a deadlock involving all the threads. क्या बोलिएगा बच्चों चैट बॉक्स में? Is there any potential possibility of a deadlock happening between the threads? Between the 5 threads क्या कभी deadlock हो सकता है? बोलिएगा. Come on, tell me the answer please. That's very simple to analyze for the deadlock. Can a deadlock happen here? Yes, deadlock can happen. कैसे होगा? With preemptive execution between 2 down operations. ये 2 down operations के बीच में अगर आप preempt करोगे, ये 2 down operations के बीच में आप preempt करोगे तो deadlock भी होगा. तो deadlock भी होगा. Yes. Wait on S preempt. Second thread. Wait on S preempt. Third thread. तो मतलब 5 बार 5 threads इंक्रीमेंट करोगे, काउंटर की S की वैल्यू 0 रहेगी, सेकेंड थ्रेड पे आकर सब प्रोसेसेस ब्लॉक हो जाएंगे. So therefore I can have deadlock also. I can have deadlock also. So as an MSQ question, A plus B plus D is the correct answer for this. Is the correct answer for this. So this ये तो बहुत सिंपल क्वेश्चन है. इसका आंसर दे दीजिएगा जल्दी से. इसका आंसर दे दीजिएगा जल्दी से. Come on, tell me. The value of counting semaphore is 10. It will become 7 after what? B. 3 down operations. Yes, 3 down operations you perform, that is correct. क्या इससे भी हो जाएगा? 5 अप ऑपरेशन करने से 15 होगा. 15 minus 2 नहीं होगा. 2 अप ऑपरेशंस करो आप, 12 होगा. 12 minus 5 is 7 again. So therefore D is also correct. D is also correct. बिल्कुल सही. चलिए इसका आंसर बता दीजिएगा प्लीज. बहुत सिंपल है, इंटरेस्टिंग क्वेश्चन है. दिस इज इंटरेस्टिंग क्वेश्चन. पीपल जनरली गेट कंफ्यूज विद दिस क्वेश्चन. कम ऑन बॉयज एंड गर्ल्स. इज इट स्ट्रिक्ट ऑल्टरनेशन? मैं आपसे पूछना ये चाह रहा हूं, इज दिस क्वेश्चन रिलेटेड टू स्ट्रिक्ट ऑल्टरनेशन? इज इट स्ट्रिक्ट ऑल्टरनेशन? टेल मी क्लियरली एंड केयरफुली. इज इट स्ट्रिक्ट ऑल्टरनेशन? बोलिए. इज इट स्ट्रिक्ट ऑल्टरनेशन और नॉट इज माई क्वेश्चन. नो, दिस इज नॉट स्ट्रिक्ट ऑल्टरनेशन. सिमिलर है लेकिन नहीं है, सेम नहीं है. क्यों? यहां पर देखिएगा, दिस प्रोसेस 0, प्रोसेस 1, बोथ ऑफ देम आर लूपिंग विद द सेम कंडीशन. कंडीशन सेम हो तो स्ट्रिक्ट ऑल्टरनेशन नहीं होगा. कंडीशन सेम हो तो स्ट्रिक्ट ऑल्टरनेशन नहीं होगा. हियर आई हैव टर्न इक्वल टू 0, टर्न इक्वल टू 0. Initial value of turn is also 0. Look at this. Turn is also initialized to 0. So this process will come and loop here. This process will come and loop here. Both of them will get stuck. So this will lead to what? Deadlock. Deadlock होगा. Deadlock होगा ना? Come on, tell me. So therefore this solution encounters deadlock. This solution violates whenever there is deadlock, violation of progress. I hope you understand. This is not a correct 2-process synchronization. So therefore the correct answer happens to be C and D. Correct option happens to be C and D. ठीक है? So that's the point. B is correct. This solution violates mutual exclusion requirement. No mutual exclusion. See, if no process is allowed to enter critical section, then mutual exclusion is still said to be guaranteed. It is not like assignment. See, it is not a C code. One assignment, say one symbol is missing, does not mean here also you have. Here also you have. Here also you have. Some people are asking why mutual exclusion is not violated. This solution violates mutual exclusion. Is saying mutual exclusion is said to be violated. Listen to me, boys and girls. Mutual exclusion is said to be violated if two or more processes enters critical section together at the same time. If two or more processes enter critical section together at the same time, then mutual exclusion is violated. Then mutual exclusion is violated. यहाँ पर दो processes critical section में एक साथ जा नहीं सकते, so therefore it guarantee mutual exclusion. Therefore it guarantee mutual exclusion. How deadlock is possible? See, very clear, very clear. Process P1 comes and gets stuck here. No process is allowed to enter critical section. Both of them are infinite loop. That is a deadlock. That's a deadlock. और जब deadlock होगा तो progress satisfy नहीं होगी. Progress satisfy नहीं होगी. Whenever there is a deadlock, progress dissatisfaction. So therefore both the options are correct. Both the options are correct. चलिए आगे बढ़ेंगे. अब आगे बात deadlocks के ऊपर ही एक small discussion करेंगे और प्रॉब्लम्स सॉल्व करने की कोशिश करेंगे. तो चलिए बच्चों, two or more processes are said to be in deadlock if and only if they wait for the happening of an event which would never happen, right? Many counter examples we have given for deadlock handling, including in semaphores and other aspects. Rakshit Sri, you cannot say like that. If mutual exclusion is satisfied, deadlock will not happen, deadlock will happen, nothing like that. But only condition is if there is bounded waiting dissatisfaction, starvation will happen. If there is a deadlock, progress is dissatisfied. This is the point we always say. Are you getting my point? So that's the point. So that is the concept of deadlock. Then we study a concept called system model. Then we talk about resource allocation graph, RAG, having set of vertices and set of edges, right? And we studied the characteristic of deadlock with regard to resource allocation graph, right? That if there is a cycle, there may or may not be a deadlock, but if there is a deadlock, there must be a cycle. Second characterization that we studied with regard to deadlock is the necessary conditions. तो देखिए हमने कहा 4 necessary conditions है: mutual exclusion, hold and wait, no preemption and circular wait. मतलब जो भी सिस्टम में ये 4 कंडीशंस एप्लीकेबल होंगे विथ एंड नॉट और, there must be mutual exclusion, there must be hold and wait, there must be no preemption and there must be circular wait, then in such case there is always possibility of deadlock. तो मतलब ये है कि if one or more of these conditions is not applicable in such a system, deadlock never happens. So that is called the characterizations of deadlock. So this is the concept. Next we have deadlock handling strategies for dealing with deadlock. तो बच्चों जल्दी मुझे लिख के बताइएगा what are the various deadlock handling strategies. थोड़ा ब्रीफ डिस्कशन कर लेंगे, फिर इसके बाद प्रॉब्लम सॉल्विंग पर चले जाएंगे स्ट्रेट अवे. So essentially we have different approaches for dealing with deadlock. One is called prevention. Next is avoidance. Third one is detection and recovery. And the third approach, last approach is ignorance. Generally we say ignorance is no strategy. And avoidance is done through Banker's algorithm. ठीक है, चलिए एक बार ब्रीफ डिस्कशन कर लेंगे सभी स्ट्रैटेजीज का. Deadlock is prevented by dissatisfying one or more of the necessary conditions. Dissatisfying one or more necessary conditions. How is avoidance done? Avoidance is done by basically maintaining state of system as always safe. and this is based on some a priori knowledge or a priori information. A priori knowledge or a priori information. Maintain the state of the system and always try to maintain the system state in safe mode. Never allow the system to become unsafe. That is avoidance, Banker's algorithm. Detection and recovery is a reactive approach. You try to react. लास्ट पॉइंट यहां पर मुझे कहना है आपको, बहुत ज्यादा इंपॉर्टेंट पॉइंट है बच्चों. जनरली पीपल मेक मिस्टेक्स. सो रिमेंबर, इन अवॉइडेंस द स्टेट ऑफ द सिस्टम, इन अवॉइडेंस द स्टेट ऑफ दिस सिस्टम कैन बी आइदर सेफ और अनसेफ. इन अवॉइडेंस, ये बहुत ज्यादा इंपॉर्टेंट पॉइंट है, बच्चे मिस्टेक करते हैं, इसलिए मैं आपको दोहरा रहा हूं. इन स्टेट ऑफ ए सिस्टम, in state of a system, in the case of avoidance algorithm, the state of the system is either said to be safe or unsafe, is said to be safe or unsafe. Whereas in the case of detection and recovery, the state of system is either said to be safe or deadlock, is said to be safe or deadlock. Are you getting my point? Is said to be either safe or deadlock. Just a second. Hello, okay. हाँ अंकित, ये अभी मेरा सेशन चल रहा है, तो कोई एक स्टूडेंट है, उसमें बिलियनियर पाथ बोल के है, देखो चैट बॉक्स में. हाँ, बिलियनियर पाथ, वो अब्यूसिव कमेंट डाल रहा हूँ मेरे रिलीजन के ऊपर, इसके ऊपर. तो जरा देखो, बोलो. हाँ, जरा देख लो. So this is detection and recovery. This is a very important point. This is a very, very important point. ठीक है. So avoidance algorithm, the state of a system is either said to be safe or unsafe. Second important point is every unsafe is not deadlock, but every deadlock is unsafe. So मतलब अगर आप अवॉइडेंस एल्गोरिथम के लिए समझो, इफ दिस इज माय सिस्टम, वेरी इंपॉर्टेंट पॉइंट बच्चों, प्लीज गौर कीजिएगा. डोंट ट्राई टू कॉन्सेंट्रेट ऑन इररिलेवेंट थिंग्स. So this is safe, this is unsafe, and let's say this is deadlock. This is deadlock. There is a lot of misconception with regard to this point. There is a lot of misconception, confusion with regard to this point. इसलिए मैं थोड़ा इस पर टाइम स्पेंड कर रहा हूं, बच्चों गौर कीजिएगा. This is as far as avoidance is concerned. This is as far as avoidance is concerned. The basic objective of avoidance algorithm, listen to me. The basic objective of avoidance algorithm is to always operate the system in safe mode. Operate the system in safe mode. That is, never allow the system to become unsafe. Unsafe is not deadlock. Unsafe is not deadlock. Unsafe का मतलब यह है कि potentially the system may go into deadlock. If you are not careful now, unsafe का मतलब यह है, अगर आप at any time if you are trying to say that my system state is unsafe now, it means that if you are not careful now, if you don't bring your system into safety, it is possible, it is probable, ये हो सकता है कि आप आगे deadlock state में जाओगे. So unsafeness is not deadlock. Unsafeness is trying to only indicate that you have to be careful. You have to be careful. If you are not careful now, there is a probability that in future you may go into deadlock state. तो जनरली बच्चों में कंफ्यूजन होता है कि अनसेफ मतलब डेडलॉक में हो गया. नहीं, डेडलॉक इट इज नॉट. इट इज लाइक ए वार्निंग. इट इज लाइक ए वार्निंग सिग्नल कमिंग फ्रॉम द सिस्टम दैट यू हैव टू बी केयरफुल नाउ. यू ब्रिंग योर सिस्टम बैक टू सेफ्टी. ये है बेसिकली द कॉन्सेप्ट ऑफ safeness or unsafeness. So again I repeat, the basic objective of deadlock avoidance is to operate the system in safe mode. Never allow the system to go into unsafe state. If you still continue to basically operate the system in safe mode, if you still continue to operate the system in unsafe mode, then there is a probability that very soon you may go into deadlock state. ये है बेसिकली द कॉन्सेप्ट ऑफ अवॉइडेंस. ओके बच्चों, थैंक यू सो मच. लेट अस कॉन्सेंट्रेट ऑन द प्रॉब्लम. लेट अस इग्नोर अबाउट ऑल दैट नॉनसेंस. we'll just focus on our studies. That is more important, right? That is more important. Let's continue. तो अब रही बात बच्चों डिटेक्शन एंड रिकवरी की. डिटेक्शन एंड रिकवरी. In detection and recovery, this is just like reactive approach. Reactive approach. That means here the system will react. React to what? React to deadlock. तो यहां पर deadlock होगा. Deadlock हो सकता है. So there are two things here. There is no concept of unsafeness. यही point मैं बार बार कह रहा हूं बच्चों. In the case of avoidance, there is a possibility of unsafeness. There is no possibility of deadlock. यहां पर deadlock हो ही नहीं सकता, कभी भी नहीं आएगा. It is like proactive approach. Deadlock कभी भी नहीं आएगा. That's why we are saying it is avoidance. That's why we are saying avoidance. We are avoiding the deadlock. How? By maintaining the system state in always in safe mode. By operating the system always in safe mode. That's how we are avoiding. Right? तो यहां पर होगा safe और unsafe. यहां पर होगा safe और deadlock. अगर आप गलती से unsafeness बोलोगे डिटेक्शन एंड रिकवरी में, it is wrong. It is wrong. डिटेक्शन एंड रिकवरी में अनसेफनेस कभी भी नहीं आएगा. कभी भी नहीं आएगा. वहां पर सिर्फ सेफ रहेगा या सिर्फ डेडलॉक रहेगा. That is the concept. It will react. That's why when you observe that the system has entered deadlock, you react to it. How? Through recovery. What are recovery approaches? Recovery approaches are like process termination or killing the process, and the other is resource preemption. Both of them will lead to starvation. उसी तरह prevention में भी there is a possibility of starvation. Starvation can happen here also. When you are trying to prevent by dissatisfying the one or more of the necessary conditions, then definitely starvation will happen. Then finally बच्चों last strategy है ignorance. Deadlock ignorance का मतलब है no strategy. Or what is the name of the algorithm generally we use for deadlock ignorance? Can you write down in the chat box, please? Come on, tell me. What is the name of the algorithm? What is the name of the algorithm for ignorance? Tell me, please. Yes, it is called ostrich algorithm. Why it is called ostrich algorithm? Just like the ostrich bird basically ignores the problem, it ignores the problem, right? It ignores the problem that it is facing. Right? So that is called ostrich algorithm. Like whenever a sandstorm comes, ostrich apply no strategy. And then it simply closes its eyes and face and say that, okay, with time it will pass on. The problem will be overcome. That is not going to happen. Right? That is not going to happen. So therefore, ostrich algorithm is no strategy. And I told the point, if you remember and recollect, I told the point that our operating system, desktop operating system, Linux, Unix, and Windows, they don't follow any strategy. No deadlock handling strategy is applicable with deadlock ignorance. So in this desktop operating system, they don't apply any strategy. That means they follow deadlock ignorance. So that is the philosophy. तो फिर यहाँ पर क्वेश्चन आएगा, जब सर अगर none of the contemporary desktop operating systems या personal PC based operating systems are applying deadlock ignorance, then which operating systems apply the strategy like prevention or avoidance or detection and recovery? I told the point. So basically prevention, avoidance and detection and recovery, these strategies will be used in such operating systems where you cannot afford the system to go into deadlock. You cannot afford the system to go into deadlock. In such cases, we have to go for prevention. Like real-time operating system, embedded operating systems, basically go for application of deadlock handling strategies. अब आप बोलोगे क्यों अप्लाई नहीं करेंगे हम विंडोज में या लिनक्स में, लाइनक्स में? बिकॉज applying these strategies like prevention, avoidance, detection and recovery is a very costly operation. It involves a lot of cost. It consumes a lot of resources. So therefore we can't afford to apply deadlock handling strategies in such contemporary desktop operating systems. तो चलिए बच्चों कुछ क्वेश्चंस लेकर अंडरस्टैंड करेंगे, राइट? ये पूरा नोट्स है मेरे, आप बाद में देख सकते हो उसे. क्विकली विल टेक अप सम प्रैक्टिस क्वेश्चंस और उसके बाद मोस्ट इंपॉर्टेंट टॉपिक मेमोरी मैनेजमेंट में आएंगे. मेमोरी मैनेजमेंट में पर्टिकुलरली जो इंपॉर्टेंट टॉपिक्स है अच्छा फोकस करेंगे, लाइक मल्टी लेवल पेजिंग एंड अदर्स. इन्वर्टेड पेजिंग है, मल्टी लेवल पेजिंग है, सेगमेंटेशन है, फिर उसके प्रॉब्लम भी देखेंगे. कम ऑन, टेक इट क्विकली, वर्क आउट दिस क्वेश्चंस. टेक अप दिस क्वेश्चन बॉयज एंड गर्ल्स. What is the answer for this? Which of the following statements is or are true? MSQ with respect to deadlocks. Circular weight is a necessary condition for the formation of deadlock. Correct. In a system where each resource has more than, देखिएगा बच्चों important choices है ये. In a system where each resource has more than one instance, multi-instance, a cycle in its wait for graph indicate the presence of a deadlock. Yes or no? No. It is only a necessary condition but not sufficient condition. हाँ, अगर single instance of resource होता तो answer correct होता. Solving questions, and the question was the major methods for allocating disk space that does not include space, but in CO we studied space are widely okay. Okay. If the current allocation of resources to processes leads the system to unsafe state, then deadlock will necessarily occur. No, deadlock is only an, unsafeness will always not lead to deadlock. मैंने अभी कहा false है ये. If the resource in the resource allocation graph of a system, if every edge is an assignment edge, then the system is not in deadlock. Absolutely correct. Only hold is not deadlock. Hold and wait is deadlock. ये important point है. Hold and wait. Every every hold is not deadlock. अगर हर प्रोसेस सिर्फ होल्ड कर रहा है रिसोर्सेस को तो वो डेडलॉक नहीं है. Sorry. So the correct answer for this is A plus D. Okay. Come on, tell me the answer for this. Tell me the answer for this second question. Very simple question. Practice question here. This is not like MSQ. Tarang Kumar Singh, I am unable to understand what are you saying. Tarang Kumar Singh, आप मुझे DM कीजिएगा टेलीग्राम में, then we'll have a discussion. What is the answer? Very simple question. 1 mark question. And aid means help. To determine the deadlock occurrence, a tool you can say. Tool. Deadlock occurrence is resource allocation graph. There is nothing like starvation graph, inversion graph or none of the above. चलिए next question, इसका जल्दी बता दीजिए आंसर. This is an important question. I will mark it as a star topic. Star topic. Come on, tell me. देखेंगे कौन बताएगा आंसर. Come on, what is the answer? Consider the following snapshot of a system running in concurrent process. Process I is holding xi instances of resource R. All instances of resource R are currently in use. Okay, place a request for at most by I. So therefore, if you try to draw a chart here I have process I, and then this is the request or allocation and request. Okay, and this is available. So I have process P1, P2, so on, some process PP and PQ and so on, Pn. Allocation is x1, x2, xp, xq and so on, xn. y1, y2, this is 0 plus 0, yn, available copies are 0. This is the data set. Current allocation, and these are requests of the processes. So what is going to happen? At time, I can basically deallocate xp and xq. These two processes are completable. So when they are completable, my available will become xp plus xq. Because they will release the resources. वो resources अपने छोड़ देंगे. So when it releases the resources, xp plus xq become my available. So he's asking, which of the following condition guarantee that no other process apart from P and Q can complete execution? Guarantee that no process could complete. मैं क्वेश्चन को रिवर्स कर दिया हूं. What was asked in gate, I have reversed the question. So that means with this available copies, you should not be able to satisfy request of any process. You should not be able to satisfy. So that means if this is less than the minimum of the request, so minimum of yk, k lying between 1 and n, k is not equal to p and q. So correct answer is A. xp plus xq will become my available. So with that available, you should not be able to satisfy any minimum request. So if it is less than min of this, if it is greater than or equal to min, then this is deadlock free operation. If it is greater than or equal to min, then this is deadlock free operation. This is for deadlock, this is no deadlock. ये beauty है question की. This is the beauty of the question. This is deadlock condition. Deadlock होगा इससे deadlock नहीं होगा. So that is the concept of this question. I hope you understand what I am trying to say. This is deadlock free. The option C is deadlock operation. This is deadlock free operation. I hope you understand. चलिए नेक्स्ट क्वेश्चन देखेंगे. ये मैं आपको होमवर्क के लिए प्रैक्टिस के लिए छोड़ रहा हूं. दिस इज जस्ट लाइक योर बैंकर्स एल्गोरिथम. आप कर सकते हो आराम से, कोई प्रॉब्लम नहीं है. थोड़े रीजनिंग और कॉन्सेप्चुअल क्वेश्चंस लेके आगे बढ़ जाएंगे. चलिए इसका जल्दी आंसर बता दीजिएगा. बहुत सिंपल है. टेल मी द आंसर फॉर दिस. दिस इज वेरी सिंपल क्वेश्चन. Come on, tell me the answer for this. चलिए, the three processes P1, P2, P3 shares a resource R having 4 copies. Each process can request a maximum of k copies. Resource instances can be requested and release only one at largest value of k. So it can request k, it can request k, it can request k. What is the largest value of k? To avoid deadlock. So suppose if I take k is equal to 2, if I write like every process needs 2 copies of R, if every process needs 2 copies of R, then definitely there will never be a deadlock. 1 copy भी होगा तो deadlock नहीं होगा 2. लेकिन if every process requests 3 copies, there is a possibility of deadlock. So the correct answer is 2. Very simple question. चलिए इसका आंसर बता दीजिएगा जल्दी से. Tell me the answer for this question. A system shares 9 tape drives. The current allocation and maximum requirement of tape drives is given. So there are 9 copies. So available, how many are there? We can write down here. So I have given 3, 4, 5, 6, 7, available are 2. The need of each process, you can say max minus current allocation. The need is max minus current allocation. Max minus current allocation need. So 7 minus 3, 4, 6 minus 1, 5, and then 5 minus 3, 2. So safe and not deadlock, because I can satisfy this 2, then it will return, this will become 5, then I can satisfy either of them. So therefore, safe and not deadlock, correct answer is B. Tell me, this is important. This is important. Come on, tell me the answer for this. Immediately after this, we will start memory management. Deepanshu Jain. Memory management immediately इसके बाद start करेंगे. चलिए start करेंगे. Processes should acquire all the preventing deadlock in a system with mutual exclusive resources. Process should acquire all the resources at the beginning of execution. If any resource is not available, all resources acquired so far are released. This is possible for prevention. The resources are numbered uniquely and processes are allowed to request for resources only in increasing order. Circular weight. The resources are numbered uniquely and processes are allowed to request for resources only in decreasing order. Circular weight. The resources are numbered uniquely. A process is allowed to request only for a resource with resource number larger than its currently had. This is also possible. So all are possible. So any one of 2, 1, 2, 3, 4. Correct option is D. Very correct. ये simple question है, आप workout कर सकते हो. अब हम मोस्ट अवेटेड टॉपिक, मैं भी चाह रहा था जल्द से जल्द हम मेमोरी मैनेजमेंट स्टार्ट कर थोड़ा फोकस करेंगे, पर्टिकुलरली पेजिंग एंड देन परफॉर्मेंस ऑफ पेजिंग, टीएलबी एंड अदर थिंग्स. ओके, मल्टी लेवल पेजिंग एंड ऑल दैट, विल कॉन्सेंट्रेट ऑन दिस. चलिए स्टार्ट करेंगे डिस्कशन. सेंट्रल टू द ऑपरेशन ऑफ मेमोरी मैनेजमेंट, सेंट्रल टू द ऑपरेशन ऑफ ए डिजिटल कंप्यूटर इज मेमोरी. यहां पर मेमोरी का मतलब है मेन मेमोरी. मेमोरी मैनेजमेंट इज वन ऑफ द वेरी इंपॉर्टेंट फंक्शंस ऑफ ऑपरेटिंग सिस्टम. ठीक है, मेमोरी मैनेजमेंट इज वन ऑफ द वेरी इंपॉर्टेंट फंक्शन ऑफ ऑपरेटिंग सिस्टम. तो इफ यू सी जस्ट अ टॉपिक लाइक फंक्शंस एंड गोल्स ऑफ मेमोरी मैनेजर, लेट अस डिस्कस दिस. फंक्शंस एंड गोल्स ऑफ मेमोरी मैनेजर, जिसके बेसिस पर आपको काफी अच्छा समझ में आ जाएगा. चलिए स्टार्ट करेंगे. द फर्स्ट इंपॉर्टेंट फंक्शन ऑफ मेमोरी मैनेजर इज एलोकेशन. जब कोई भी प्रोसेस आप मेमोरी में लाओगे, राइट, जब जो भी प्रोसेस आप मेमोरी में लाओगे, यू हैव टू एलोकेट स्पेस. तो कैसे आप एलोकेट करोगे? कंटीग्यूअस एलोकेट करोगे, नॉन कंटीग्यूअस करोगे, सेंट्रलाइज करोगे या डिसेंट्रलाइज डिस्ट्रीब्यूटेड अप्रोच फॉलो करोगे, किस तरीके से करोगे? सो दैट इज एलोकेशन. ठीक है. फिर उसके बाद सेकेंड इंपॉर्टेंट फंक्शन इज प्रोटेक्शन. इंपॉर्टेंट फंक्शन इज प्रोटेक्शन. ये बहुत ज्यादा इंपॉर्टेंट है. प्रोटेक्शन का मतलब ये है, सुनिएगा, इफ आई लोड मेमोरी, इफ आई सी द मेमोरी व्यू, दिस इज ऑपरेटिंग सिस्टम and this is called user area. This user area can have multiple programs loaded in it. I have program P1, P2, P3, P4. So after loading this program in this is called the address space of the process. So this process should confine its execution to this address space. अगर ये process, if it is interfering into operating system area or other process area, this is not allowed. This is not allowed. ये है protection. ये है protection. How do we make sure that the process loaded in its address space do not interfere with other process area? उसके लिए आप हार्डवेयर यूज करोगे, लाइक लिमिट रजिस्टर, बेस रजिस्टर, पेज टेबल के थ्रू आप कर सकते हो. ये है प्रोटेक्शन. नेक्स्ट इंपॉर्टेंट फंक्शन ऑफ मेमोरी मैनेजर इज एड्रेस ट्रांसलेशन, कन्वर्टिंग लॉजिकल और वर्चुअल एड्रेस टू फिजिकल एड्रेस. एड्रेस ट्रांसलेशन सपोर्ट. नेक्स्ट इंपॉर्टेंट फंक्शन इज डी एलोकेशन. जब प्रोसेस अपना एग्जीक्यूशन कंप्लीट कर लेगा, यू हैव टू डी एलोकेट द मेमोरी एंड पुट इट बैक इनटू अवेलेबल फ्री पूल. दैट इज डी एलोकेशन. फिर लास्ट में आप बोलोगे फ्री स्पेस मैनेजमेंट. कि भाई जब मेमोरी divided into two parts, used area and free area, so how do we manage? How does the memory manager keep track of free space manager, free area of memory? So boys and girls, these are the functions of memory manager. To carry out these functions, it should support some goals. Can you please tell me what are the important goals of memory manager? Come on, tell me. What are the important goals of memory manager? Tell me fast. Yes, VM is virtual memory, correct. The important goal of memory manager is efficient utilization of memory. मतलब it should have less wastage. Generally wastage का जो term है जो यूज किया जाता है वो है fragmentation. You should have less fragmentation. As you remember, fragmentation is of two types. One is internal fragmentation and the other is external fragmentation. Here, second important goal of memory manager is management of execution, management of execution of larger programs, bigger programs in small memory areas. Like the concept of virtual memory basically support this. Virtual memory hai, overlays hai, they support this. These are the goals. Yes. So functions and goals of memory manager. To carry out this functionality and implement the goals, we classify memory management techniques. Into two types. One is contiguous and the other is non-contiguous. One is contiguous allocation, the other is non-contiguous allocation. Right? Contiguous allocation and non-contiguous allocation. Contiguous allocation is like centralized allocation. That means the whole process is at one place, contiguously placed. Okay? And this is like distributed approach, decentralized. The program may be divided into parts and different parts of the program may be placed in different areas of memory. That is non-contiguous. Okay? Examples of techniques that comes under contiguous allocation is basically like partitions, overlays, and then we have also even swapping systems. Under non-contiguous, we have techniques like paging, segmentation, and then we have combined approach, segmented paging. These are non-contiguous. So brief review, partitions as you know is of two types. We have fixed partitions and dynamic or variable partitions. This static and this dynamic. So what happens in fixed partition? We divide the user space into multiple fixed partitions, multiple fixed blocks. Each partition, each block can hold one process. No two process may be in one partition, or no one process may be in single partition, or no one process will be occupying multiple partitions. That is partitioning. One of the important challenge in partitioning technique is to decide which partition, कौन से partition में हम process को store करेंगे. उसके लिए we have partition allocation policies. काफी questions आ चुके हैं previous papers में. So you have to remember very carefully with regard to all the partition allocation policies. Come on, tell me. Write down in the chat box. What are various partition allocation policies, boys and girls? Write down in the chat box and tell me what are various partition allocation policies. Come on. How to place the process, in which partition are we supposed to place? partition allocation policies. Come on. Buddy system is a slight variation of variable partition. थोड़ा एक discussion यहाँ पे करूँगा. Please understand. What are various partition allocation policies? Yes, we have first fit, next best fit, next fit, and last worst fit. First free begin of first fit, smallest free begin of best fit, next free partition from where last allocation was made, next fit, and the largest free partition is worst fit. These are the various allocation policies. Fixed partitions will suffer from internal fragmentation, will never have external fragmentation. Variable partitions will never have internal fragmentation, may have external fragmentation. Limited degree of multi-programming in fixed partitions and flexible degree of multi-programming in variable partitions. So that is the comparison between various partition allocation policies, various partition allocation policies, or various techniques of partitions, fixed and variable. उसी तरह overlays basically support the goal of managing larger program in small memory area. Just let me have a quick look whether do we have any question related to partitions. I'll just have a look in the practice questions. Just wait for a second. Okay. So बच्चों, almost 2 hours we have taken the class so far. So before I start paging and multi-level paging, segmented paging and virtual memory, let's have a small break of 10 minutes. 2 hours almost we have taken. So another maybe 1 hour we may continue. So therefore we will have a small 10 minutes break so that I will also get refreshed and then you will also get refreshed. So 10 minutes, right now it is 8 p.m. We started at 6. So we'll meet after 10 minutes. 10 minutes break. ठीक है ना? 10 minutes. 8:10 we will start the class sharp. चलिए बच्चों, आई एम बैक एज आई सेड, सो वी कंटिन्यू आवर डिस्कशन। तो मैंने ब्रेक पे जाने से पहले स्टार्ट किया था टॉपिक ऑफ मेमोरी मैनेजमेंट, contiguous or non-contiguous allocation. Within that contiguous allocation we have seen partitions. I hope I am audible and visible. बोलिएगा, I'm audible and visible. Just give me the clearance before we continue. Okay, very good. So next we will start our discussion with non-contiguous allocation. Non-contiguous allocation में start करेंगे the basic concept of paging. चलिए यहाँ पर हम डिस्कस करेंगे non-contiguous allocation. बेसिक जो फिलॉसफी होगी विथ रिगार्ड टू नॉन कंटिग्यूअस एलोकेशन, इट गोज लाइक दिस. प्लीज सी हियर ऑन बोर्ड. इमेजिन दिस इज अ सीपीयू. The address generated by the CPU for non-contiguous allocation is called logical address or virtual address, and the address needed for the memory to be accessible. मेमोरी एक्सेस करने के लिए जो आपको एड्रेस लगेगा, जो एड्रेस चाहिए, दिस फिजिकल एड्रेस, दिस इज मेन मेमोरी, फिजिकल एड्रेस स्पेस, main memory. The address needed for accessing that is called physical address or effective address or real address. So welcome back all of you, please. So this physical address is needed to access the main memory for accessing your instruction or data, which is called content. So to basically convert the logical address to physical address, we need a setup which is generally called memory management unit, address translation unit called memory management unit. The job of this memory management unit is to take the generated logical address into corresponding page register, relocation register, page table, segment table, and so on. So based on this, we anticipate, we understand that the first step of non-contiguous allocation is to study about the organization of this logical address space. And second step is organization of this physical address space. And the third and final step is the organization unit. So we basically study, why is gone? Just a second. Now clear? Okay. Breaking. Okay, just maybe there may be some internet issue. Is it okay now? Audibility? बोलिएगा. Audibility is okay? Lagging sometimes. ठीक है, breaking हो रहा है, audibility issue है. देखेंगे, थोड़ी देर देखेंगे. Okay, clear. So organization of logical address space, organization of physical address space, and organization of memory management unit are the three important steps in the implementation of non-contiguous allocation technique. So the first non-contiguous allocation technique that we take on for discussion is called paging. So in paging, step number A is organization of logical or virtual address space. How is this organized? Briefly, I will tell. We will divide this address space into equal size units, which are called pages. This page 0, page 1, page 2, page 3, so on. This fixed page size. So we take some page size and divide them into pages. Based on this, the important formulas that goes are number of pages. How do you get number of pages? The total size of logical address space divided by page size will give you number of pages. Every page is assigned a unique page number. Page number कैसे निकालोगे आप? P. Page number is given by log of number of pages to base 2. This is measured in bits, right? Page offset कैसे निकालोगे? Page number is used to select the page. Offset is used to select a page word within the page, byte within the page. That is given by page size to base 2. And based on this, we will formulate the logical or virtual address format as follows. Page number and offset. This is your logical address or virtual address format. Again, I repeat. Number of pages is logical address space divided by page size. Page number is log of number of pages to base 2. Alternatively, from here you can say capital N is equal to 2 power P, and from here I can say page size is equal to 2 power D. ठीक है? So that is the concept. Same way, we can have the organization of physical address space. We can have the organization of physical address space with the convention that physical address space will be constituted in the form of or visualized in the form of frames. These are frames. With the concept that frame size is generally same as page size, so that one frame can hold one page. So maybe you can say I can store one page here, maybe another page here, maybe another page here. Pages of the logical address space are stored in frames of memory. So this frame 0, frame 1, frame 2, and so on. So this is your physical address space. तो concept क्या बनेगा? Concept ये बनेगा, number of frames, let us say number of frames will be given by physical address space divided by page size. Number 2, frame number will depend on number of frames, so log of m to base 2. Number 3, page offset is same as frame offset. So here I will write frame offset is equal to page offset. is equal to D. So therefore the physical address format will have two parts, F and D. F and D. So these physical address space organization in paging, and those are the relevant formulas. Last point ये है बच्चों, the memory management unit here in paging is called page table. Is called page table. Third step. Sometimes we call page map table or address translation table. Either of them. हर प्रोसेस का अपना पेज टेबल होगा, यूजिंग विच इट विल ट्राई टू कन्वर्ट or it will try to translate the logical address to physical address using page table or page map table. So how is page table organized? See on board. This page table of a process PI. So it is constituted in terms of number of entries. These are called page table entries. Page table entry. Generally this is measured as some E bytes, let us say, in bytes. Page table entry. ठीक है? So this is entry for page 0, page 1, page 2, page 3 and so on. So this is some entry for page number P, and this page is kept in frame F. So page table entry contain the frame number in which the page is present. Page table entry contain the frame number in which the page is present. So using this page table, how do you translate the logical address to physical address? So when we run any process and generate the virtual address or logical address, we break this into two parts, page number and offset. Using page number, listen to me, using page number we index into page table to get the frame number. यहाँ से हम frame number निकालेंगे. This frame contain the page, so therefore we add the offset D. This is your physical address, and using this physical address you access physical address space. ये है simple concept of paging. Yes, because address space is same. Panda, Vyomakesh Panda, address space is same. So therefore it shares. So this is the concept. यहाँ पर बात आपको remember करने की ये है, page table size is always given by number of pages multiplied by entry size. This is the formula. This is in bytes. So this is in bytes, assuming E is in bytes. Assuming E is in bytes, you can use that formula for computing the page table size. Next important aspect that we need to focus on is the performance of paging. Performance of paging. There are two aspects. One is temporal and the other is spatial. Other is spatial. Temporal is with respect to time. What does effective memory access time become with simple paging? That we have discussed so far. यहाँ पर जो हम देखे थे, with respect to this technique, what is effective memory access time? So first, this page table is kept in memory. So I need an access time of M to access main memory. Then I need a final access time M to access the main content, instruction or data. So for every reference I need two accesses, 2M. So effective memory access time become 2M. If you want to reduce this effective memory access time and bring it closer towards M, then we have to add the concept of TLV implemented through cache memory. Implemented through cache memory. TLV stands for translation look aside buffer. अगर इसका access time, imagine if it is C और hit ratio अगर X हो, then with TLV your effective memory access time will become into C plus M plus miss ratio 1 minus X into C plus 2M. ये आपका equation बनेगा for effective memory access time using TLV. Many questions were asked based on this concept. Next aspect is spatial locality. That means space optimization. तो किस चीज का space optimization करोगे आप यहां पर? That is nothing but with regard to page table. Page table size. जैसे ही page table size अगर बढ़ जाएगा आपका, then it starts consuming lot of memory in space, in terms of space. ठीक है? So question is, we don't want to associate a larger page table with the process. We want page tables to consume less memory. तो कैसे आप reduce करोगे? What are the different approaches of reducing page table size? The different approaches of reducing page table size is to increase page size. First approach is increase page size. As the size of page increases, page table size decreases. क्यों? कि number of pages कम होंगे तो page table size कम होगी. लेकिन अगर पेज साइज इंक्रीज करोगे आप तो इंटरनल फ्रैगमेंटेशन बढ़ेगा. Increasing the page size will lead to increase in internal fragmentation. So we don't require this, we don't desire this. The second approach is to go for multi-level paging, MLP. The basic notion of multi-level paging are two things. Number one, to reduce the size of page table overhead. Number two, to basically support the concept of contiguity in pages. लेकिन अगर आपका पेज टेबल एक पेज से ज्यादा पेजेस में अकोमोडेट हो रहा है तो कंटिग्यूटी कंस्ट्रेंट लॉस हो जाएगी आपकी, बिकॉज वी वांट द पेज टेबल टू बी कंटिग्यूअस. सो देयरफॉर वी गो फॉर मल्टी लेवल पेजिंग. सो दैट आइडियल कंडीशन हमेशा याद रखिएगा, जो आउटर मोस्ट पेज टेबल होगा प्रोसेस का, जो ओरिजिनल पेज टेबल होगा प्रोसेस का, दैट शुड बी ऑक्युपाइंग एटलीस्ट इन वन, एट मोस्ट इन वन फ्रेम. इट शुड नॉट बी मोर देन साइज ऑफ अ फ्रेम. इट शुड ऑक्युपाई वन पेज साइज. ठीक है? दैट इज आइडियल कंडीशन. So for that we have to go for multi-level paging. The other approach still which you can use is maybe inverted paging. These are all the techniques which are used to support the goal of having lesser page table size overhead or even hashed paging. Even hashed paging. So these are the various paradigms which you can follow for reducing the page table size. In this regard, before I come to multi-level paging, I would like to ask one simple question. पेज साइज बच्चों हमेशा याद रखिएगा, यहां पर नेक्स्ट पेज में आपको लिख के बताऊंगा. पेज साइज इज अ वेरी डायनामिक एस्पेक्ट. दिस विल हैव इंपैक्ट ऑन इंटरनल फ्रैगमेंटेशन. दिस विल इंपैक्ट पेज टेबल साइज ओवरहेड एंड इट विल ऑल्सो हैव एन इंपैक्ट ऑन पेज फॉल्ट रेट, जो हम नेक्स्ट टॉपिक में डिस्कस करेंगे, पेज फॉल्ट रेट. If you want lesser internal fragmentation, small page size. लेकिन small page size से होने से क्या होगा, page table size बढ़ जाएगा. If you want smaller page table size, large page, लेकिन large page होने से internal fragmentation होगा. So in this regard, we ask this: what should be the optimal page size? What should be the optimal page size so that the internal fragmentation is less and also page table size overhead is also optimal. So does anybody remember what is the formula? Suppose if I say the virtual address space size is S bytes and page size is given by P. Page table entry size is E bytes. With respect to these parameters, do you remember what is the formula for optimal page size? So that these two parameters are under control. What is optimal page size? एक 2 mark question आ सकता है. So this is given by under root of 2 into SE. Under root of 2 into SE. एक simple 2 mark question पूछा जा सकता है based on this concept. Then second aspect we said is multi-level paging. What is the basic notion of multi-level paging? In simple terms, when I say multi-level paging, it is nothing but application of the concept of paging on page table. I used to generally say that paging as a concept, this own terminology of mine, paging as a concept involves 3 steps. Dividing the address space, any address space, logical address space or maybe next page table address space or whatever, dividing the address space into pages, into chunks or pages or units, blocks, right? And then second point is storing the pages in frames of memory or in main memory. Third point, access the pages through page table. जहां पर भी आप paging technique apply करोगे, you require a page table. So like for example, at the outset for one level paging, this is my virtual address space and let's imagine this is my physical address space. ठीक है? And let's say this is my page table. So let me write So please follow. In brief, I am trying to tell you what is multi-level paging. This virtual address space, this physical address space, this is page table, this page table. The boys and girls, please have a look. By convention, we are dividing this virtual address space into pages. Pages. This P0, P1, P2, P3, so on. Physical address space is divided into frames, visualized in the form of frames where frame size is same as page size. So maybe I stored some pages here, P0, P5, P20. These are pages of virtual address space. Yes, please follow me. Then to access these pages, I need this page table. ये हमारा simple concept of paging है. So the entry for page 0, page 1, page 2, page 3, page 4. So these are frame numbers. These are frame numbers. F dash, F double dash, something like this. Frame numbers. One level paging. So when this page table has become large and contradicting or trying to negate the concept of contiguity and become large, right? So when it become large, so what we have to do is we have to have a smaller page table with the condition that the page table should fit in one page. So now it is not fitting in one page. So what should I do? I should apply recursively the concept of paging on page table. मतलब ये page table को you divide this into some pages, some chunks. So this is, you can call P0, you can call P1 or P-0, P-1, P-2, P double dash 2 like this, something like this, or P-2. So these are called pages of page table. This should be equal to the size that number of entries the page table can hold. One page can hold number of entries. Chunk size may be same as page size. Or number of entries that one page can, of the page table that one page can hold, that should be the size of page table. Or I would say select some page size and divide this into pages. Select some page size and divide this page table into pages. These pages are also stored in frame, also stored in main memory. Maybe I store P-0 here, whatever pages, whatever number of pages are needed, P-1, etc. जितने भी pages जो useful हो आपके of this page table, you store them in frames of memory. So as I said, paging on page table concept, मतलब you have divided this page table address space into chunks or pages, stored those pages or chunks in required pages, necessary pages in the frames of memory, and finally to access that page, those pages in memory, you require page table. इसे हम generally page directory भी बोलते हैं, page directory, which is also called outer page table. Outer page table. Number of entries in outer page table is equal to number of pages. यहाँ पर जितने भी pages है उतने entries रहेंगे. तो लेकिन जितने पेजेस आपने मेन मेमोरी में स्टोर किए हैं ऑफ दिस पेजेस ऑफ दिस पेज टेबल, जितने पेजेस आपने स्टोर किए हैं उतने ही एंट्रीज यहां पर वैलिड होंगे, बाकी के इनवैलिड होंगे. सो नाउ नो मोर दिस पेज टेबल एंटायरली विल बी स्टोर्ड इन मेमोरी. व्हाट विल बी स्टोर्ड इन मेमोरी इज दिस, एंड द रिक्वायर्ड पेजेस ऑफ पेज टेबल विल बी इन मेमोरी. दैट्स इट. That is the main advantage of multi-level paging. So this whole big large page table will not be in memory. Only the required pages will be in memory. जितने आपको एड्रेस स्पेस के लिए जरूरी है उतने ही आप स्टोर करोगे एंड यू एक्सेस देम थ्रू दिस आउटर पेज टेबल. तो दिस फ्रॉम द एंट्री ऑफ दिस आउटर पेज टेबल यू एक्सेस पेज ऑफ इनर पेज टेबल. फ्रॉम द पेज ऑफ इनर पेज टेबल यू एक्सेस पेज ऑफ वर्चुअल एड्रेस स्पेस. मतलब दिस कॉन्सेप्ट इज जस्ट लाइक योर डबल पॉइंटर concept. From here you are accessing page of inner page table and from there you are accessing page of virtual address space just like a double pointer. ये है मल्टी लेवल पेजिंग कॉन्सेप्ट का, टू लेवल पेजिंग का कॉन्सेप्ट. इसी तरह इफ यू बिलीव दैट दिस आल्सो हैज बिकम लार्ज, अगेन डिवाइड दिस इनटू चंक्स और पेजेस, स्टोर देम इन फ्रेम्स एंड एक्सेस देम थ्रू अदर पेज टेबल, 3 level पेज टेबल, 4 level पेज टेबल एंड सो ऑन, लाइक दैट इट गोस. ठीक है. सो दैट इज द बेसिक आइडियोलॉजी ऑफ मल्टी लेवल पेजिंग. तो चलिए नेक्स्ट कॉन्सेप्ट है सेगमेंटेशन का. ये तो कॉन्सेप्ट है पेज टेबल का, ये टीएलबी का कॉन्सेप्ट है एंड दिस इफेक्टिव मेमोरी एक्सेस टाइम जो हमने डिराइव किया था. सेगमेंटेशन का एक कॉन्सेप्ट लेकर हम आगे बढ़ जाएंगे. देखिएगा सेगमेंटेशन का कॉन्सेप्ट क्या है. paging does not preserve users view of memory allocation. Paging does not guarantee users view of memory allocation. To guarantee users view of memory allocation, which say that the program is divided into segments or logical units like functions, blocks, procedures, data structures, you follow segmentation. Program is divided into logical units called segments. Segments are stored in their entirety in main memory, and to access the segment we require segment table. फर्क इतना ही है, segments or may be of different sizes, pages may be of same size. Pages will be of same size, right? And the logical concept like the programmer's view of memory allocation is always guaranteed in segmentation. Paging does not guarantee users view of memory allocation. बाकी का तो कॉन्सेप्ट बिल्कुल सेम है as far as performance is concerned. देखिएगा segment table है and that is a physical address space, these are logical address space. These are the segments, main function, GCD function, square root, k, etc. These are segments. These segments are stored in memory in contiguity and you are accessing them through segment table. एक सिंपल 1 मार्क क्वेश्चन आ सकता है बेस्ड ऑन सेगमेंटेशन. ठीक है, एक सिंपल क्वेश्चन आ सकता है ऑन सेगमेंट टेबल. आई कैन गिव लॉजिकल एड्रेस, you have to find physical address, so you can find that through this segment table. So that is the simple segmentation policy. मुझे कोई चैट बॉक्स में लिख के बताएगा कि when should we combine or introduce paging into segmentation. उसके लिए एक आपको यहां पर बता दूं, if you compare paging versus segmentation, paging, segmentation, the issue of comparison between both of them is let us say see on board, internal fragmentation, external fragmentation. Tell me please in the chat box, paging suffer from which fragmentation? Simple 1 mark question. Paging suffers from which fragmentation? Paging may have internal fragmentation. Paging में कभी भी external fragmentation नहीं होगी. Paging में external fragmentation कभी भी नहीं होगी. Segmentation में internal fragmentation कभी भी नहीं होगा. External fragmentation होगा. This will happen in physical address space. This will happen in last page. This will happen in last page. ठीक है? चलिए. To overcome this problem of external fragmentation in segmentation, we introduce paging. So paging is introduced in segmentation to overcome the problem of external fragmentation. ये बात याद रखिएगा. And second need for introducing paging into segmentation is to reduce the size of segment table. These are the two major reasons for introducing paging in segmentation. Previous questions में ये दोनों concepts के ऊपर questions आए हैं. मैं अपने पेड बैचेस में जनरली हैव सॉल्व्ड बोथ द क्वेश्चंस. सो दैट इज द रीजन फॉर दिस. सो दैट इज द आर्किटेक्चर. यही डायग्राम जो हम क्लास में भी देखे थे. फ्रॉम सेगमेंट टेबल वी रेफर पेज टेबल ऑफ सेगमेंट एंड देन वी एक्सेस द पेज ऑफ द सेगमेंट इन मेन मेमोरी. ये है आर्किटेक्चर ऑफ सेगमेंटेड पेजिंग. सेगमेंटेड पेजिंग आर्किटेक्चर का डायग्राम ये है. चलिए आगे देखेंगे वर्चुअल मेमोरी. एक ब्रीफली आउटलाइन कर सीधा प्रैक्टिस क्वेश्चंस पे आएंगे ऑफ वर्चुअल मेमोरी. वर्चुअल मेमोरी के प्रैक्टिस क्वेश्चंस पर आएंगे. ठीक है, तो चलिए सी हियर ऑन बोर्ड. व्हाट इज वर्चुअल मेमोरी? द बेसिक आइडिया ऑफ वर्चुअल मेमोरी इज टू गिव एन इल्यूजन टू द प्रोग्रामर that a huge amount of main memory is available or huge amount of memory is available for execution of larger programs in small memory area. मतलब वर्चुअल मेमोरी आपको परमिट करेगी, आपको अलाउ करेगी एग्जीक्यूशन ऑफ ए बिगर प्रोग्राम इन स्मॉल मेमोरी एरिया. मतलब कोई अगर आपका प्रोग्राम साइज है 100 KB लेकिन अवेलेबल मेमोरी सिर्फ 50 KB है, तो हम 100 KB प्रोग्राम 50 KB मेमोरी में कैसे एग्जीक्यूट करेंगे? ये है कॉन्सेप्ट ऑफ सपोर्टिंग द पैराडाइम ऑफ एग्जीक्यूशन ऑफ लार्जर में प्रोग्राम इन स्मॉल मेमोरी एरिया. सो दिस इज डन थ्रू द कॉन्सेप्ट ऑफ डिमांड पेजिंग. डिमांड पेजिंग. डिमांड पेजिंग का मतलब है लोडिंग द पेजेस ऑन डिमांड एट रन टाइम. मतलब यह है कि फर्स्ट स्टेप वी स्टोर द प्रोग्राम ऑन डिस्क इन द फॉर्म ऑफ पेजेस, लोड द पेजेस व्हाट एवर यू कैन अकोमोडेट इन मेमोरी. तो ऐसा हो सकता है कि मेरा प्रोग्राम है 8 पेजेस लेकिन मेरे पास अवेलेबल फ्रेम्स है 4. सो हाउ डू वी मैनेज द एग्जीक्यूशन ऑफ एन 8 or 10 पेज प्रोग्राम इन ओनली 4 फ्रेम्स ऑफ मेमोरी, लेस फ्रेम्स? दिस इज डन थ्रू डिमांड पेजिंग. तो मतलब जब प्रोसेस अपना एड्रेस जनरेट करेगा फॉर पेज रेफरेंस, दैट पेज मे बी प्रेजेंट इन मेमोरी और मे नॉट बी प्रेजेंट। अगर पेज मेमोरी में अवेलेबल है तो आप कन्वेंशनल पेजिंग टेक्निक से एक्सेस करोगे, अगर अवेलेबल ना हो मेन मेमोरी में, देन वी कॉज ए फॉल्ट, पेज फॉल्ट होगा, ऑपरेटिंग सिस्टम विल मेक श्योर दैट इट विल ब्रिंग द पेज फॉल्टेड पेज फ्रॉम डिस्क टू मेमोरी। दिस कॉल्ड पेज फॉल्ट सर्विस। जो टाइम लगेगा पेज फॉल्ट सर्विस करने के लिए, हम उसे पेज फॉल्ट सर्विस टाइम कहेंगे। So therefore, in that regard, the effective memory access time for demand paging बनेगा page hit ratio into memory time, page miss ratio into page fault service time, right? तो page fault service में require page replacement। जब अगर आपके पूरे के सारे frames totally loaded है, तो which page should be removed to bring the faulted page? Page replacement technique. We may have basically first in first out or last in first out, LRU, MRU, optimal, LFU, MFU, and so on. Different page replacement techniques. Nishu Kumar, page replacement technique is very important. काफी क्वेश्चंस आ चुके हैं पेज रिप्लेसमेंट टेक्निक पर, तो पेज रिप्लेसमेंट टेक्निक अंडरस्टैंड करना जरूरी है। सो देयरफॉर द परफॉर्मेंस ऑफ पेजिंग विल डिपेंड ऑन द पेज फॉल्ट रेट। हायर द पेज फॉल्ट रेट, more will be the effective memory access time. Lesser the page fault rate, less would be the effective memory access time. तो काफी ज्यादा बच्चे कंफ्यूज होते हैं ये इक्वेशन में। इफेक्टिव मेमोरी एक्सेस टाइम फॉर डिमांड पेजिंग विल बी टेकन एज पेज हिट रेशियो इनटू मेमोरी टाइम, पेज मिस रेशियो, पेज फॉल्ट रेशियो इनटू सर्विस टाइम, वेयर m इज द मेमोरी एक्सेस टाइम, s इज द सर्विस एक्सेस टाइम। यहां पर बच्चे जनरली बोलते हैं सर व्हाई नॉट वी आर राइटिंग m प्लस m, व्हाई नॉट वी आर राइटिंग s प्लस m। काफी ज्यादा डाउट्स रहता है बच्चों को। आई हैव इवन दो आई टोल्ड वेरी क्लियरली दिस एवरेज मेमोरी एक्सेस टाइम और इफेक्टिव मेमोरी एक्सेस टाइम, this is not going to consider the time for address translation. On an average, time for hit in memory, on an average, time for servicing the page fault. That's it. So you're not going to write like 1 minus p into m plus m as we see in the case of paging with TLB without page faults. Without page faults. जब TLB की बात होगी तो हम we are going to write like m plus m, but TLB ना हो, general effective memory access time है डिमांड पेजिंग में, ये है कॉन्सेप्ट। ठीक है। There were many questions which were asked in previous gate papers based on this concept alone. कई questions आ चुके हैं। That's why this formula is taken from Galvin as it is. तो चलिए बच्चों, ये है मल्टीपल मेमोरी का परफॉर्मेंस इशू है एंड ऑल दैट। सो डायरेक्टली आई थिंक पेज रिप्लेसमेंट एल्गोरिथम तो आई डोंट हैव टू डिस्कस, यू नो इट वेरी वेल। फर्स्ट इन फर्स्ट आउट कैसे वर्क करेगा, लास्ट इन फर्स्ट आउट कैसे वर्क करेगा। अब थोड़े प्रैक्टिस क्वेश्चंस ले लेते हैं टू बेसिकली रिवाइज योर कॉन्सेप्ट्स, टू मेक योर बेसिक अंडरस्टैंडिंग प्रोफाउंड। चलिए फर्स्ट क्वेश्चन है, आंसर दीजिएगा प्लीज इसका। मल्टी लेवल पेजिंग के क्वेश्चन से स्टार्ट कर रहे हैं हम। गेट 2023 का क्वेश्चन है। बोलिएगा आंसर, व्हाट इज आंसर फॉर दिस? मल्टी लेवल क्वेश्चन का आंसर, मल्टी लेवल क्वेश्चन है, मल्टी लेवल पेजिंग का क्वेश्चन है, गेट 2023 का क्वेश्चन है। या हियर आई एम टेकिंग मल्टी लेवल पेजिंग का ही क्वेश्चन लिया हूं डायरेक्ट। इसके लिए इफ यू रिमेंबर आई हैव गिवन ए फॉर्मूला फॉर यू बेस्ड ऑन मल्टी लेवल पेजिंग। व्हाट शुड बी द आउटर पेज टेबल साइज, व्हाट शुड बी द आउटर पेज टेबल साइज टू फिट इन वन फ्रेम ऑफ मेमोरी। ये क्वेश्चन में अज्यूम करके चलना है हमें, मल्टी लेवल पेजिंग में अज्यूम करके चलना है कि ओपीटी आउटर पेज टेबल should fit in one page or frame is a meaning. इसका if you remember I have given the question. Suppose imagine that the size of virtual address space is 2 power s bytes and let's say page table entry size is 2 power c bytes. Page size 2 power x bytes, ठीक है, 2 power x bytes, let us say like this, and number of levels of paging, like in this question is L. Let us say write L. Given these parameters, the outer page table size, OPT size, with L levels of paging will be given by, if you remember my formula, I gave it in the class, I derived it, 2 power L S minus L into X, right, plus L into C. This is in bytes. This formula I derived, if you remember. So here if you see, the size of virtual address is given, right, L levels of paging. Page size is given 4 KB and page table entry size is given. So let us write virtual address space और virtual address की size लिख लेंगे direct. Virtual address is nothing but 57 bits and page size is 2 power 12. Page table entry size 8 bytes, 2 power 3 bytes. Everything is there. So outer page table size is 2 power 12. 2 power 12 is equal to 2 power S57 minus, we want to find the value of L into page size. This value of X is 2 power 12. So 12 plus L into C is how much? C is 3. So therefore this will become 2 power 57 minus 12L plus 3L. So minus 9L is equal to 2 power 12. So therefore 12 is equal to 57 minus 9L. So therefore 9L is equal to 57 minus 12 is equal to 7 minus 2 is 5 and this is 45. So L is equal to 45 by 9. 5. So answer is 5. Answer is 5. So remember this as the formula. Nishu Kumar is asking ये formula कहां से आया? खजाने से आया. खजाना. We have derived this formula, Nishu Kumar, in our paid batches. Right? Or the other approach is through addressing. Address format से भी आप कर सकते हो. Address format से भी आप कर सकते हो. मैंने दोनों मेथड क्लास में बताए थे. दोनों मेथड. This is a traditional method and the other method is address method. जो भी मेथड आपको आसान लगेगा वो आप फॉलो करो. Another method, दो मेथड्स. मैं ट्रेडिशनल मेथड फॉलो करता हूं क्योंकि ट्रेडिशनल द लॉजिकल अप्रोच ऑफ मल्टी लेवल पेजिंग है ये. चलिए ठीक है, आगे बढ़ेंगे. ये डायरेक्ट आप कर सकते हो. मैं थोड़े टिपिकल क्वेश्चन लूंगा, जो डायरेक्ट क्वेश्चन है हम छोड़ देंगे. चलिए इसका आंसर बताइए. इंपॉर्टेंट है, स्टार क्वेश्चन. दिस स्टार क्वेश्चन. Come on, boys and girls, tell me the answer for this. Come on, this is a star question. रीजनिंग क्वेश्चन है, लॉजिकल क्वेश्चन है, एप्टीट्यूड है. चलिए बच्चों जल्दी आंसर दीजिए, वेरी इंपॉर्टेंट. Sam, I am too concerned with your concern also. I am also concerned. I am also unhappy with that. But circumstances had basically created that situation. That's what I would say. Sam. चलिए start करेंगे. The TLB performs an associative search in parallel on all its virtual valid entries using page number. Correct. If the virtual address of a word given by CPU has a TLB hit, but the subsequent search for the word results in a cache miss, then the word will always be present in main memory. Correct? That is TLB hit होगा तो word main memory में होगा, अगर cache में नहीं है तो. Next, the memory access time using a given inverted page table is not always same for all incoming virtual addresses. बिल्कुल, ये भी बिल्कुल सही है. In a system that use hashed page tables, if two distinct virtual addresses v1 and v2 map to the same value while hashing, then the memory access time of these addresses will not be the same. This is also true. मैं थोड़ा चेंज कर दिया हूं, मैं थोड़े ऑप्शंस चेंज कर दिया हूं यहां पर. This is a gate question, उसको चेंज किया. C is false. The memory access time using given inverted page table is not always same. Please understand. For all incoming virtual addresses. Yes, it is not true. C is true. Shishti Chaudhary. Actually क्या था gate exam में this was memory access time will be same था वहां पर. मैं यहां पे not कर दिया. See, inverted paging का concept क्या है यहां पर explain कर रहा हूं. Inverted paging. Listen to me, boys and girls. The inverted page table. Inverted page table. These are entries. Number of entries equal to number of frames. ठीक है? This is frame number 0, frame number 1, frame number 2 and so on. Internally you have page number I, page number J, page number K and process ID. Here I have process I, process J, process K, something like this. Please understand. Please understand. Now when the processor CPU generate an address, this is address 1, address 1. So page number and offset and process ID here. So we take a search, we take process ID and page number, or we'll write like this, page number P and process ID. क्या करेंगे हम? Using this we index into this, we search by content. ये content से मैच करेंगे, ये entry से मैच करेंगे, इससे मैच करेंगे. Suppose if it is found here with access time T1, access time T1, यहां पर order of n time लगेगा. इन द कन्वेंशनल पेजिंग में ऑर्डर ऑफ 1 लगेगा. ठीक है ना? यहां पे सर्च बाय कंटेंट है, सर्च बाय कंटेंट. अब नेक्स्ट टाइम इफ आई जनरेट अनदर एड्रेस, एड्रेस 2, p डैश d डैश d रहेगा, p डैश d. सो दिस एड्रेस 2, ये शायद एड्रेस यहां पर हो, यहां पर हो, तो ये टाइम लगेगा T2, T1 एंड T2 सर्च बाय कंटेंट. सो T1 एंड T2 में भी डिफरेंट. यस इट इज डिफरेंट, इट में भी डिफरेंट. वही पूछा गया है ऑप्शन, रीड कीजिएगा. द मेमोरी एक्सेस टाइम यूजिंग अ गिवन इन्वर्टेड पेज टेबल इज नॉट ऑलवेज सेम फॉर इनकमिंग वर्चुअल एड्रेसेस. यस इट विल नॉट बी सेम, इट विल नॉट बी सेम. समटाइम यहां पर होगा, समटाइम यहां पर होगा, समटाइम. तो अगर आप कंपेयर करो, ये द गेट क्वेश्चन था, गेट क्वेश्चन में यहां पर नॉट वर्ड नहीं था, मैंने ऐड किया वर्ड नॉट. गेट में था इज ऑलवेज सेम, रॉन्ग है वो. नॉट ऑलवेज सेम करेक्ट होगा. Got it? So therefore that is our answer. तो ये भी correct answer है. So all 4 options are correct. All 4 options are correct. So boys and girls, that's why I'm saying, so be careful while reading choices. Questions like this are important. इसीलिए मैंने कहा this is an important topic. हाँ, TLB में constant time लगेगा, that is correct. TLB में constant time लगेगा. चलिए नेक्स्ट क्वेश्चन देखेंगे. हाँ, इसका आंसर बताइए, इसका आंसर बताइए. अगेन एमएसक्यू, एमएसक्यू क्वेश्चन. Very simple. He is asking is or are true. Correct. Paging helps solve the issue of external fragmentation. Correct. Change करेंगे. Is correct. Page size has an impact on internal fragmentation. Yes or no? Yes, this is also correct. Paging incurs memory overheads. Correct. Multi-level paging is necessary to support pages of different size. No, wrong. So therefore the correct answer is ABC. ABC. Be careful. Be careful. ABC is correct. आई एम रिपीटेडली सेइंग बॉयज एंड गर्ल्स, MSQ क्वेश्चंस इस तरीके के आर इंपॉर्टेंट. नेक्स्ट, पेस्ट फॉल्ट का पेपर है, आप आराम से कर सकते हो, कोई इशू नहीं है. ये भी बहुत सिंपल क्वेश्चन है. चलिए फिर भी आप वर्कआउट करके बता दीजिएगा. जो बच्चे कहते हैं सर वो इफेक्टिव मेमोरी एक्सेस टाइम में डिमांड पेजिंग के M+M करना चाहिए या S+M करना चाहिए, उन सभी क्वेश्चन, उन सभी स्टूडेंट्स के लिए ये क्वेश्चन एग्जाम्पल है. You have to use directly this formula for demand paging. Effective memory access time is equal to P into S plus 1 minus P into M. अगर नहीं आप यहां पर M+M करोगे, S+M करोगे और वर्कआउट करोगे तो ये क्वेश्चन सॉल्व नहीं होगा. ये गेट का क्वेश्चन है, मैंने यही बात आपको कहना है. The answer for this question can come only with this. It cannot come with others. Yes, Nitin Rayal, I will share the PDF. I will share the PDF in the group, my Telegram channel. I will share the PDF in my Telegram channel. If you have not subscribed, subscribe to it. Join that channel. So if you substitute all these things in this equation, I am very sure you will get the answer as B. I am sure, I think so. I am putting a question mark. Check, answer is B. ठीक है, B is correct ना? Yes. चलिए बच्चों, फाइल सिस्टम्स के ऊपर मैं चाह रहा हूं कि आप लोग थोड़ा स्टडी कर लीजिएगा. फाइल सिस्टम्स के मेरे नोट्स देख सकते हो या फिर मेरे पेड बैचेस के नोट्स पे रिवाइज कर लीजिएगा. जो नेक्स्ट सेशन होगा हमारा ऑन PYQs, वहां पर मैं फाइल सिस्टम के कुछ क्वेश्चंस लेकर आऊंगा और वहां पर हम डिस्कस करेंगे. इंपॉर्टेंट टॉपिक्स यहां पर मैं लिखूंगा आपके लिए फाइल सिस्टम में, जो आपको इंपॉर्टेंटली पढ़ना है. जो इंपॉर्टेंटली पढ़ना है, सबसे पहले आप पढ़िएगा, रिवाइज कीजिएगा, डिस्क, फिजिकल स्ट्रक्चर ऑफ डिस्क. इंपॉर्टेंट टॉपिक्स लिख रहा हूं मैं, जो आपको फोकस करना है फाइल सिस्टम में. फिजिकल स्ट्रक्चर ऑफ डिस्क, जहां पर आपको डिस्क की कैपेसिटी डिटरमिन करना है और इनपुट आउटपुट टाइम मालूम करना है. एंड थर्डली you will have to focus on what do you call data transfer rate, DTR. फिर second is allocation methods. Allocation methods like 3 allocation methods: contiguous, non-contiguous या linked allocation, and third one is index allocation. And with respect to index allocation, प्रिडोमिनेंटली जो आपको पढ़ना है यूनिक्स आइनोड स्ट्रक्चर. यूनिक्स आइनोड स्ट्रक्चर, यूनिक्स आइनोड स्ट्रक्चर पढ़िएगा. नेक्स्ट, आई वांट यू टू बी वेरी क्लियर विथ फ्री स्पेस मैनेजमेंट एल्गोरिथम्स. And last, disk scheduling. इसमें से मैं चाहूंगा कि आपने जो वेरी इंपॉर्टेंटली पढ़ना है वो एलोकेशन मेथड्स है, फ्री स्पेस मैनेजमेंट है, डिस्क स्ट्रक्चर है. ये तो बहुत सिंपल टॉपिक है. दिस वेरी वेरी सिंपल. डिस्क शेड्यूलिंग एवरीबडी विल वर्क आउट. यस, दैट्स करेक्ट राकेश जोशी. तो बॉयज एंड गर्ल्स, इंपॉर्टेंटली ये टॉपिक के ऊपर फोकस कीजिएगा. कंटिन्यूअस एलोकेशन, लिंक्ड एलोकेशन, इंडेक्स एलोकेशन, पर्टिकुलरली यूनिक्स आइनोड स्ट्रक्चर के ऊपर कॉन्सेंट्रेट कीजिएगा. देन दैट शुड बी मोर देन सफिशिएंट इनफ फॉर इट. और ये तो ओवरलैपिंग टॉपिक है. यू बेसिकली हैव दिस इन द सब्जेक्ट ऑफ COA आल्सो. डिटेल में आपको CO में पढ़ाया जाएगा. CO से आप रेफरेंस कर सकते हो, पर्टिकुलरली एड्रेसिंग इन डिटेल. सो फोकस ऑन दिस एस्पेक्ट्स विथ रिगार्ड टू फाइल सिस्टम. इसके कुछ प्रॉब्लम्स मैं नेक्स्ट जो हमारा सेशन होगा, नेक्स्ट जो सीरीज है, PYQ सीरीज है शायद, और हो सकता है शायद मेरी क्लास कल ही हो. तो अगर कल मेरी क्लास है ऑन PYQ, देन वी आर गोइंग टू डिस्कस बोथ PYQs ऑन एल्गोरिथम्स and also PYQs on operating systems. वर्चुअल मेमोरी में दो चीजें और भी आप पढ़ सकते हो, थ्रैशिंग एंड वर्किंग सेट स्ट्रैटेजी. How to control thrashing through working set strategy, that is also an important. सृष्टि हो सके तो कल हम कर लेंगे क्योंकि आज काफी टाइम हो चुका है, right? Almost 3 hours done. So first session was also for almost 3 hours. This also 3 hours. So that should be sufficient enough. And next class I will take up PYQ series में आपको अगर चाहो तो working set strategy का एक क्वेश्चन करा दूंगा मैं, ठीक है? अब I don't want to stretch for more because your time is also important and concentrate on revision. बच्चों काफी लोग मुझे पूछ रहे हैं, काफी लोग पूछ रहे हैं with regard to what should be done. Just एक 2 मिनट के लिए एक जनरल मोटिवेशन आपको सबके लिए, right? Maintain peace, calm and composure in your mind. देखिएगा डर आपको लग रहा है, ये नेचुरल चीज है, हर एक को लगेगा डर, हर एक को लगेगा. तो आपने कोई ज्यादा सोचना नहीं है विथ रिगार्ड टू डर हो रहा है, विथ रिगार्ड टू कैसे होगा. डोंट थिंक ऑफ एंड रिजल्ट. Keep yourself very calm and composed. Don't study any new topic. Don't study any new topic. जो आपने पढ़ा हो उसी को अच्छे तरीके से रिवाइज कीजिएगा. PYQs थोड़ा और एक बार हो सके तो जितना हो सके आप कर लीजिएगा. उसी लिए हम कल PYQs लेकर आ रहे हैं आपके लिए, इंपॉर्टेंट PYQs, बोथ सब्जेक्ट्स एक साथ सॉल्व करूंगा मैं इवनिंग क्लास में शायद. एंड देन you also follow on this. Don't try to make comparison with others. Don't try to see your performance in mock test or other test of any test series. ये मत सोचिएगा मेरा परफॉर्मेंस खराब हो रहा है या अच्छा हो रहा है. Don't look at that. I have already told you, once again I'm telling you. So thank you बच्चों so much for your patience listening. So we'll attend tomorrow's session for